ಹೋಸ್ಟ್ ಮಾಡ್ತೀನಿ. Start video wait.
Good afternoon, everyone. I welcome you all to day 3 of Faculty Development Program, which is Smart Cities Concept Strategies, Opportunities, and Challenges, organized by Department of Civil Engineering, Nitte Meenakshi Institute of Technology, Bangalore, which is a fully sponsored program under ATAL AACT. So, just a recap of the 2 days we had before. The day 1, followed by the inauguration program, we had a presentation by BSc Rao sir. Later, there was an address by Dr. Sheikh Chhabra, market manager, on considerations for planning and implementing fire safety in smart cities. Yesterday, we had Dr. D.R. Ravi sir delivering the address on smart city projects in India, planning and inspection public policy. Today, day 3 of the program, we have altogether 3 sessions altogether. The first session will be delivered by Dr. G. Raghav sir. Second session will have Dr. V. Ramchandra sir, and the third one will be by Dr. V. Ramchandra. Sorry, Dr. G. Before starting the first session, I would like to take this up. I also welcome my co-host, Dr. Maulya Madam. She is an assistant professor in Department of Civil Engineering, NMIT. I also welcome all other moderators, HOD of the department, Dr. Bharti Ganesh, Manjunath sir, Brunel ma'am, and Ghana, who are the moderators of this FDP. Before we start the first session, I take this opportunity to welcome our first speaker, Dr. G. Raghav sir. Dr. G. Raghav sir obtained his B in Civil Engineering from Sri Jayachamara College of Engineering, University of Mysore in 1980. Later, he got his MTech in Industrial Structures from the Karnataka Regional Engineering College, now NITK Surathkal, in 1984. Later in 1999, he completed his PhD in Structural Engineering from the College of Engineering, Guindy, University. After a brief stay at the Karnataka Regional Engineering College as a lecturer in the year 1983, he joined Structural Engineering Research Center, Chennai, as a scientist in June 1983. On completion of an illustrious service of 34 years, he retired in July 2017 as Chief Scientist and Head of the Fatigue and Fracture Laboratory of CSIR SCRC. The Fatigue and Fracture Laboratory is recognized as state-of-the-art national facility for specialized experimental investigations on large-size structural components and structures under real-life loads and environment. His areas of specialization are fatigue behavior of structures and structural components, design of structures for fatigue loads, and experimental investigations on static, fatigue, and corrosion fatigue behavior of large-size structural components. He has many awards and recognitions to his credit, among them DAT Fellowship for Advanced Studies at the Technical University Berlin in 1998 to 1990. Later, Awareness Award for Best PhD Thesis by the Corrosion Society of India in 2000. Next, participation in the 23rd Indian Scientific Expedition to Antarctica and structural assessment of the second Indian research station MAI-3 in Antarctica from December 2003 to April 2004. Then Chairman Technical Core Group for the construction of third Indian research station Bharti in East Antarctica. Later in 2014, NICE International Gateway India Society Corrosion Awareness Award for Excellent Laboratory. He has almost 163 technical papers to his credit in various reputed journals and proceedings. The awards to his papers include Suchit Kumar Ghosh Memorial Prize by the Institution of Engineers, Certificates of Merit by the Institution of Engineers, Dr. M. Ramaya Prize for Best Technical Paper published by the scientists of CSIR SERC, Certificates of Merit for Best Technical Papers published by scientists of CSIR SERC. He is also a life member of the following technical societies: Institute of Engineers, Indian Concrete Institute, Indian Society for Non-Destructive Testing, Computer Society of India, Indian Structural Integrity Society, Society for Failure Analysis, Instrument Society of India, Indian Nuclear Society, Indian Association of Structural Engineering, Indian Association for Computational Mechanics. Now, he is serving as professor in the Department of Civil Engineering, Nitte Meenakshi Institute of Technology, Bangalore, from July 2019. Now, over to speaker Dr. G. Raghav sir.
Thank you, Mashka, and you are able to hear. Is it coming?
Starting.
It's coming now. Good afternoon, everyone. And I thank NMIT for the opportunity to make a presentation on this. In my title, I have given to strategies and disaster management. And there is a secondary keyword connecting the two, that is Indian context. This is the third day of your FDP. Therefore, you must have already seen quite a few definitions of smart city. And for the presentation today, I am going by the definition.
It's not started.
Excuse me.
If it is not shared.
Internet is.
Now it's loaded. It's loaded. now.
Continue, sir.
Should I start now from the beginning?
Yes, yes. Let's do it.
They want to take on the throat.
Give us a minute, we'll be back. We have got a technical issue.
ಅಲ್ಲವ್ರು ಯಾಕಡೆ ಹೋಗಕ್ಕೆ
ಶೇರ್ ಆಗಿಲ್ಲ.
ಶೇರ್ ಆಗಿಲ್ಲ.
ಶೇರ್ ಮಾಡಲಿಲ್ಲ.
ಇಲ್ಲ
ಕ್ಯಾಮ್ರಾ
ಶೇರ್ ಮಾಡಿ
ಎಲ್ಲಿ ಅದು?
ಶೇರ್ ಮಾಡಿ ಮಂಜು.
ಶೇರ್ ಮಾಡಿ ಸರ್. ಇಲ್ಲ
ಡಿಪ್ಲೊಮಾ ಹೋಗಿರಿ ನಾವು ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ತೀವಿ ಅಷ್ಟೇ. ಆಮೇಲೆ ಯಾವ ಬ್ಯಾಚ್ ಏನದು
Yeah, can I start?
Yes.
Yeah, sorry for that disturbance and inconvenience. We are starting from the beginning. Is it okay now? Yeah. The presentation on smart cities and disaster management and in Indian context. I was telling I have two keywords in this presentation: smart city, disaster management, and there is another secondary keyword, Indian context, connecting the two. This is the day of your okay. Yes, there is little delay in the slides loading, I believe, correct? Yeah, okay. We will go slow. How to minimize this? Okay. You might have already gone through different definitions of a smart city. And for the convenience of this presentation, I am taking the definitions given by Government of India. And coming to smart city, we have this document, Smart Cities, Mission Statement and Guidelines by the Ministry of Urban Development, Government of India. And these numbers 2 and 2.1 refer to the paragraph numbers given in the document. And what does this document talk about smart city? What is a smart city? Again, all these words, the question also is taken from this document. The paragraph 2.1 says, the first question is, what is meant by a smart city? The document itself puts the question, and the answer is, there is no universally accepted definition of a smart city. It means different things to different people. Therefore, varies from city to city and country to country, depending on the level of development, willingness to change and reform, resources and aspirations of the city residents. A smart city would have a different connotation in India than, say, Europe. Even in India, there is no one way of defining a smart city. And the paragraph 2.2 of the document says, boundaries are required to guide cities in the mission, in this smart city mission. In the imagination of any city dweller in India, the picture of a smart city contains a wish list of infrastructure and services that describes his or her level of aspiration. I have again highlighted here the wish list of infrastructure and services. Later on in another slide, I am giving you the latest wish list of Bangaloreans with regard to their city. Therefore, I have highlighted it, and I will come to that later. To provide for the aspirations and needs of the citizens, urban planners ideally aim at developing the entire urban ecosystem, which is represented by the 4 pillars of comprehensive development. When it comes to development, we generally talk of 4 pillars of development: institutional, physical, social, and economic infrastructure. Social infrastructure, and then the economic infrastructure. This can be a long-term goal, and cities can work towards developing such comprehensive infrastructure incrementally, adding on layers of smartness. Here, one thing I wish all of you to remember is, when we say Bangalore is a smart city, it is wrong if I think that the city has been given the title smart city. In fact, quite a few cities have now been recognized. We call, but it is not a recognition as a smart city. Generally, every year, Government of India is calling for proposals for funding for development towards becoming a smart city. When I say Bangalore has been selected last year, it means the proposal by the city of Bangalore has been accepted, and the funding for its proposal is given to carry out those developmental activities which would take Bangalore towards achieving the goal of smart city. As it is, none of these cities have already reached the so-called smart city, and as you go by the definition, again, whether it's a smart city or not a smart city, it's up to you, and therefore it is wrong to say we are already a smart city. We have been given the funding by Government of India for developmental activities towards reaching this goal. This smart city is one side, and another side is my another keyword, disaster management. Again, for this, I go to again the Government of India source. We have the very, very important National Disaster Management Plan, NDMP 2016, when it comes to disaster management in our country. And this is published by the National Disaster Management Authority of Government of India. The paragraph 1.2 gives the vision of disaster management, which reads as: make India disaster resilient, achieve substantial disaster risk reduction, and significantly decrease the losses of life, livelihoods, and assets. These are the 3 important losses when we talk of disaster management. And when it comes to assets, what are the different assets? Economic, physical, social, cultural, and environmental. These are the assets. Therefore, you decrease the losses by maximizing the ability to cope with disasters at all levels of administrative as well as among communities. Now, one side, I have told you what is smart city. Another side, I have told you disaster management. And I have also, also have highlighted you the importance of disaster management. And do we have the connection between the two? And again, continuing with paragraph 1.8.2, disaster management, this document uses the term with the same meaning as defined in the Disaster Management Act 2005. And what is disaster management as per this document? It's a continuous and integrated process of planning, organizing, coordinating, and implementing measures which are necessary or expedients for the following: of danger or threat of any disaster, mitigation or reduction of risk of any disaster or its severity or consequences, capacity building, preparedness to deal with any disaster, prompt response to any threatening disaster situation or disaster, Can I continue now? Prompt response to any threatening disaster situation or disaster, assessing the severity or magnitude of effects of any disaster, evacuation, rescue and relief, and rehabilitation and reconstruction. Now, I want you people to think of how good, how far we have succeeded any one of these things when it comes to your surroundings, when it comes to your city or town. Slide is not changing. Now, again, I go back to the previous document of Smart Cities Mission Guidelines. That document also talks of smart solutions. The document talked about smart city. I told you about the definition. Then I showed you what I mean by disaster management, again, based on Government of India document. Now I see what are these smart solutions towards achieving the aim of making my city smart. In that document, these are the solutions listed under the headings e-governance and citizen services, waste management, water management, energy management, urban mobility, and others. In this list, unfortunately, you can see that there is no mention of disaster mitigative measures, even though you just now realized in the previous two slides that disaster management is very, very essential for your safe and quality living. And of course, you can always argue that some activities under the heading waste management and water management have some direct or indirect linkage to disaster management. The result, where is the mismatch between the smart city concepts and disaster management guidelines? When I show you these pictures, many of us in our day-to-day living in India are not used to these pictures. You probably may think there is nothing unusual. We are taking these things for granted, and we still say we are in a smart city, and these pictures are of our own so-called smart city. And also, please mind you, you think of the disasters each of these pictures are telling indirectly. You may not be aware, just you have to think. Okay, and you Google search, you get these pictures. And therefore, my question is, where we have gone wrong, where is the mismatch between the smart city concept, or forget even the smart city qualitative objective, the city and town planning concepts and disaster management guidelines. So-called IT capital of India. I call this smart city with these pictures I see every day around me, and from where I have taken these pictures for every slide and every information I am giving in my presentation, then and there I am giving the source also. And again, therefore, our effort is towards managing this disaster and build a resilient smart city. Again, these pictures have become an annual feature of us in many of the cities in our country. Again, you talk of Bangalore, you talk of Mumbai, you talk of any other important city in the nation. There were a few years back rivers which have now become huge sewer lines, drainages. And this is one such Nitte river in Mumbai. And you just think of what we have made out of this river over decades. Of course, there is consolation. Whatever pictures I showed, some of us may get consolation, by seeing similar pictures from other beautiful cities in the world. For example, I show here some pictures of the Venice floods in 2019, and some of you may realize even in 2020 you had similar flooding in Venice. That was because of the malfunctioning or not working of the control system of the floodgates. Therefore, you need to have some. These problems are not just of our own country, there are others also. Now, forget about the main cities, so-called Tier 1 cities. I'm not talking of Mumbai, I'm not talking of Bangalore. Shall I go to Tier 2 cities? Is my living comfortable there? Is my living more qualitative there? This is a picture from Shimla, and the students of disaster management. We know that landslide, we learn in the first and second chapters itself as one of the important natural hazards. And here you see the picture of landslide in this city of Shimla. And almost every year you've been reading in the newspaper, seeing in TVs, such pictures from city of Shimla or similar cities in the north. And I come to Mysore, and as yet Mysore has not yet been given the grants for developing into smart city. Therefore, as I told you earlier, in our usual sense, Mysore is still not a smart city, even though it has been already declared as a 5th cleanest city in the country and cleanest in Karnataka. That I will be coming to that later. And these are some pictures from Mysore. The point I am highlighting is, whatever pictures you are seeing here are the pictures for which we are used to. This is the way it has been around us all through. Now I come to some articles and about these pictures. What can we do about it? Or why are we that way? Or if we can do something about it, what is it that we can do? Now, in document, this reference, which has, I took this from Times of India, India Times, Bangalore Mirror, and that document again refers to the guidelines for management of biological disasters, again from NDMA, Government of India. And please concentrate here, because this is another very, very important document which is very relevant today in the midst of our this present biological disaster. You just see what we have written as a nation in July 2008. More and more people are traveling all over the world, which exposes the whole world to epidemics. As our society is in a state of flux, novel pathogens emerge to pose challenges not only at the point of primary contact, but in far removed locations. The increased interaction between humans and animals has increased the possibility of zoonotic diseases emerging in epidemic form. An overloaded urban infrastructure consequent to rapid urbanization, along with population movement, is the largest hazard the country faces in a biological disaster. I repeat this second sentence: an overloaded urban infrastructure, rapid urbanization, along with population movement, all these three are relevant in our nation, in most of our big cities. This is the largest hazard the country faces in a biological disaster. This is in 2008. Now the question is, but what must bother us is that from 2008 and last year, it was 2020, and all these 12 years, when the guidelines were approved till date, there hardly has been any preparation across the length and breadth of India in taking preventive steps and preparing to respond to a biological disaster. We took it very lightly. We wrote it in 2008. We kept quiet. Then what happened in 2020? These pictures have become a part and parcel of our life. Last few months, day in and day out, we were seeing these pictures. Why did we end up here? Why did we forget what we ourselves wrote in 2008? These are some of the issues I am trying to make you think about seriously. And mind you, this so-called COVID is one of the biological disasters listed in disaster management. Therefore, I am connecting it to the basic concepts of disaster management. Again, coming back to this present pandemic, of course, we have this tendency to just shrug it off. Okay, biological disaster of the century, some people call biological disaster of unimaginable magnitude. When will we recover? Another 30 years? I mean, 30 is considered for economic recovery, we are estimating that at least we need 30 years. Therefore, that is why I wrote 30 years. And did we go wrong somewhere collectively? If yes, where and why? These are some of the questions about the present. And what can we do when there is an act of God? What we can do? Therefore, that is another way of just taking it. It's a biological war, conspiracy raised by rogue country, etc., etc. These are some of the explanations given pandemic, but we forget what we wrote in 2008. If we were very serious about what we wrote, if we had even at least a few steps, at least the consequences, the risk involved, the vulnerability could have been much, much, much less. Therefore, that brings me to another important disaster management, disaster preparedness. Therefore, it is becoming increasingly evident now that a relatively smaller investment in disaster preparedness can save thousands of lives and vital economic assets, as well as reduce the cost of overall relief assistance. The point I'm trying to make here is just think of the present pandemic also. Even in my classes in disaster management and mitigation engineering, I keep telling the students, when you are not able to understand the explanations, think of the disaster which is familiar to you in your surroundings. Maybe the present COVID, or maybe a cyclone in your surroundings, or maybe tsunami, whatever you have experienced. Then you think of linking yourself to these explanations. Therefore, and this, whatever I have written here, I have taken from IGNOU course material. And therefore, why do we keep forgetting the basics we learn in disaster management? And I already told you, Mysore is considered as the cleanest city of Karnataka in 2020 and the 5th cleanest city of the country. These are the pictures from the city of Mysore from, last month. It is not a picture where you have gone and searched to take those pictures. I just requested a friend, when you are going around on a particular day, take these pictures and send me. The point I am trying to highlight is, these are all, we just take it for granted. Look around, this is how it is, and there is nothing wrong in it. This is how things are, fine. But basic lesson we forget, safety and hygiene in public spaces are intrinsic to disaster management and fundamental aspects of a civilized community. What am I doing? I did, not that I am trying to be pessimistic. Slowly you can see that there is also change in the tone of my presentation. And I also told you in one of the earlier slides about the wish list. And I give here the wish list for this new year from the community of Bangalore. As we enter a new year, this is Bangalore's wish list. And this wish is from on January 1st, it was in the January 2nd newspaper. Therefore, it was as on January 1st. And this wish list was collected from the community, planners, and policymakers. Therefore, you can say this is the wish list of this city. What is the wish list? Roads and footpaths, cleaner green city, focus on primary healthcare, boost for business, and tapping technology to improve policing. I'm not finding anything wrong with this wish list. The only thing I am trying to argue is there are much more pressing and basic needs, as you see in this wish list. Therefore, how can we expect the community, planners, and policymakers to think of the concept of disaster management in city administration? They do not even think of, yes, there is a concept called disaster management, which is very fundamental, which is very basic in city and town planning. And especially when you talk of smart cities, there is no other way rather than accepting it. Now I further, again, this is from January 2nd newspaper, expedite smart city projects. And our Honorable Chief Minister had the meeting of IAS officers in connection with smart city projects in the state. And some statistics for you from this document. There are, in Karnataka right now, there are 7 centrally sponsored smart city projects. As I told you already, these are the cities which have been sponsored with funding for smart city projects development. Therefore, we wrongly usually call them as smart cities. Bangalore, Belagavi, Davangere, Hubballi, Dharwad, Mangaluru, Shivamogga, and Tumkuru. And nearly 40% of our state's population resides in urban areas. And the problems faced, as per what is written here in this document, drinking water, housing, drainage, traffic congestion, etc. The point I am trying to tell is this meeting was held in the first week of January. You are still in the midst of the biological disaster of the century, and you are talking of development of the city, and you do not talk of the biological disaster, and you do not talk of disaster management explicitly when it comes to city planning. That is the point I make. Of course, there are some hopes, there are rays. Again, I take from the Hindu newspaper of January 4th, a facelift for drain connecting KR Market and Bellandur Lake. And what the work entails, you can see in the center. I am more concerned in the first half, the top of, they talk of construction of European style pathway, etc., electrical works, including ornamental lighting, and that doesn't interest me. What interests me and what I'm impressed is what is given in the bottom. You just see eliminating sewage inflow, untreated industrial effluents, dumping of garbage, silt removing from drain bed and increasing drain capacity by 5%, using natural material bioremediation techniques to improve water quality, and redesigning existing culverts and bridges to increase drain capacity. As a student of disaster management, these are the details in which I am interested, and this is the direction in which we city and town planners have to move. And now I take two important publications. You can Google search and find these publications. And now disaster management, I have told, smart cities, I have told the importance of disaster management in smart cities. Yes, there are many people who are thinking in these lines. And there is this another interesting article towards disaster resilient smart cities. Can Internet of Things and big data analytics be the game changers? Now, till now, I showed you the day-to-day pictures and the day-to-day scenario. Now, the other side, I show you the recent publications and what the academicians write about these concepts. From this, disasters, either natural or man-made, can be lethal to human life, the environment, and infrastructure. The recent advancements in the Internet of Things and the evolution in big data analytics, IoT technologies have provided an open opportunity to develop highly needed disaster-resilient smart city environment. I am not going into the discussion of these conclusions. I leave it to you how you connect the first part of my presentation till now and the second part, which I will be doing here afterwards. Novel reference architecture and philosophy of a disaster-resilient smart city, DRSC. These are the key words we have coined. Through the integration of the IoT and BDA technologies is discussed in this paper. The proposed architecture offers a generic solution for disaster management activities in smart cities. A combination of Hadoop ecosystem and Spark develop an efficient DRSC environment that supports both real-time and offline analysis. The implementation model of the environment consists of data harvesting, data aggregation, data pre-processing, and big data analytics and service platform. And for those of you like me who are not so techno-savvy, for whom these words Apache, Hadoop ecosystem, and Spark are new, I have also given here what they mean. Apache Hadoop is an open source framework written in Java that allows storing and processing of big data in a distributed environment across various clusters of computers using a simple programming constructs. And Apache Spark is an open source distributed general purpose cluster computing framework. A variety of data sets, for example, smart buildings, city pollution, traffic simulator, are utilized for the validation and evaluation of the system to detect and generate alerts for a fire in a building, pollution level in the city, emergency evacuation path, and the collection of information about natural disasters, for example, earthquakes, tsunamis. The evaluation of the system efficiency is measured in terms of processing time and throughput that demonstrates the performance superiority of the proposed architecture. The DRSC, a disaster-resilient smart city environment, would allow rapid and effective analysis backed with multi-source data for generating an early warning to citizens and assisting in the prevention, monitoring, and recovery from catastrophic situations. And this is the figure taken from the same document. You can see here a beautiful picture of what a smart city would be, including you have smart buildings, you have crowdsourcing, and you have IoT devices, satellite, RSU, cellular tower, and emergency responders. And of course, you have this Spark and Hadoop, which I just now told, and also internet, Bluetooth, Wi-Fi, etc., etc. It's up to you to decide how good we have connected the first part of my talk and the second part, which we are talking about now, and the picture which you are seeing now. Cities across the world are grown near river basin or near sea. Heavy rainfall or natural disaster like tsunami and earthquakes result in flood impacting city life. Building a right disaster management plan to handle such emergency solutions is very essential. For a better planning, a simulation platform is needed which can help government to predict the disaster situations and its impact on city. The disaster management solution includes the balanced use of resources and assets, coordination between various organizations and stakeholders, efforts of individuals, and the right knowledge of locations. Now I come to another, this is the last document I am discussing in my presentation, another important document, but a more optimistic document. I'm happy to end my presentation with this document. This is Manage Disaster and Build Resilient Smart Cities. The source is Smart Cities Council. India's ambitious smart city project needs an effective disaster management plan to combat natural disasters and man-made disruptions in smart cities. I am happy with one thing, and this is the document where they explicitly talk of disaster management inclusivity in smart city projects. Smart cities have been gathering a lot of traction of late, mostly due to the government's increased efforts to secure high-quality urban life. Looking at the rapid increase in man-made disruptions and natural catastrophes such as heavy rain and floods, disaster management and emergency response mechanisms are indisputably treated as the most integral factor for the development of smart cities. In June 2013, over 5,000 people were estimated to be dead after a series of cloudbursts that caused severe floods and devastating landslides in the North Indian state of Uttarakhand. The heavy rainfall resulted in the collapse of the tourism and hospitality sector, which contributes close to 30 to 35% Uttarakhand's GDP. Just you please think of the present pandemic also, and you draw similar paragraphs for the present pandemic. Serious misgivings were raised on the coordination between the different authorities involved in flood forecast, flood management, and backup operations. The state of affairs has not improved much during the last 5 years. Last 5 years is 2013 till 2017. In 2017, following heavy rains, the state of Gujarat more than 200 deaths. The Chennai floods have again urban planning and disaster management efforts. As India's fourth largest metropolitan city, and of course today it's a smart city as well, Chennai's lack of resilience to natural disasters is a big concern, and such instances need to be tackled with adequate IT and digital infrastructure. The authorities can minimize the flood-related destruction only if flood forecasting is accurate. In the absence of resilience to natural hazards, smart cities will not be robust enough to attract investments and employment opportunities. And again, before I close, I show here some statistics. A report by Socioeconomic and Educational Development Society, SEEDS, and the Center for Research on the Epidemiology of Disasters, CRED. 56% of smart cities in India are prone to floods. This is a huge number, mind you, which are responsible for 77% of all disasters in India. India has a mean of 11 flood events per district over the last 18 years. Report based on disaster data, these two things are based on the report of between 2000 and 2017, data between 2000 and 2017. And again, we have another report by Asian Development Bank and the Potsdam Institute for Climate Impact Research. Potsdam is next to Berlin in Germany. Asia has the highest number of people exposed to floods from possible storm surge events, particularly in China, India, Bangladesh. Exceedingly important for India to carry out risk assessments and apply modern day inventions such as IoT sensors to develop an exceptional business community plan, which we call it BCP. Efforts required to deploy efficient disaster warning systems and watershed management programs to assure that our future cities continue to function smoothly despite serious challenges as floods. And for smart solutions, the way forward, again from the document, by leveraging the benefits of big data, such as learning algorithms, IoT sensors from storm drains and satellite image review, the local government can determine when to evacuate citizens and initiate disaster preparation during the possibility of rising tides and heavy rainfall. Now I showed you the two pictures, the first half and the second half. I am closing my presentation with some closing remarks. First, giving you some selected recollections from what three previous speakers have told in the present FDP, which has some relevance and some connectivity to the philosophy with which I made the presentation today. To start with, our own director, Dr. N.R. Shetty, the first day, he talked of, unless you think of the, what we I call them the less privileged in the society, unless you think of the significance of taking on par with us, the less privileged in the society, there is, you can't say I'm a smart city and a city which is free of disaster, because we are a community and we are interconnected. And my welfare, my safety is closely interconnected with the welfare, with the peace and safety of every other individual in this global village. And the second presentation, the presentation by Dr. Gopal Krishnan, Director of CBRI in the inaugural session, he talked of very, very relevant concepts like sillage and pura. Sillage, civic amenities in villages. You see to it that villages have all the amenities which you think of, which you dream of in a so-called city. Therefore, you can, to some extent, control this unimaginable, maddening urbanization without planning. And pura, providing urban amenities in rural areas, pura. And the third presentation, yesterday's presentation, and yesterday we heard a lot about our glorious past of excellent civic planning and administration. Yes, we need to be very proud, and we have a glorious past. But then what? We should move forward, and what we build today should be much, much, much greater and better. And in disaster management subject, we have these concepts, we have these wordings of reconstruction and opportunity. When for various reasons, maybe disaster, maybe a hazard, but I got an opportunity to reconstruct. Now this smart city funding, the cities got an opportunity to reconstruct. Take this reconstruction opportunity, take these things as an opportunity for reconstructing these cities. And we also have another important concept in disaster management, that is build back better. When you are developing something, when you are building back, please build back better. These cities should be better than what they were earlier, and therefore you should be less prone to disaster, and you should be in a much better qualitative environment. The concepts of disaster management principles and practices are well established. It is not a rocket science, and they are easily available. The call of the day is realization by the planners, policymakers, and the community that the same need to be mandatorily and explicitly incorporated into the planning development agenda of our cities and towns. But also take a quick, I will tell you a few important things. Our public memory is very, very short. When you talk of disasters in India, many of us have already forgotten Bhopal gas tragedy, and we have forgotten Upahar Cinema Complex fire disaster in Delhi, and the misery we went through due to earthquake, we have forgotten, and the misery faced due to tsunami in Chennai and Tamil Nadu, we have forgotten. And mind you, terrorist attack is considered as a very, very important disaster. We have forgotten the Mumbai terrorist attack. We have forgotten the attack on our Delhi parliament in Delhi. And regular urban flooding, we have taken it as a part and parcel of our daily living. Even the present pandemic, we are in the midst of the pandemic, and most of us have already forgotten it. Therefore, the point I am trying to make is, even if some of you have realized the importance of the so-called word disaster management in city planning, that would be worth my effort. And just like your life insurance and health insurance, disaster preparedness should become a part and parcel of your personal and community living. That is the point I am trying to highlight. And before I close, I should thank my present institution, NMIT, Nitte Meenakshi Institute of Technology, and the management, and our director, Dr. N.R. Shetty, because of which I am here and I am making this presentation. And I also am indebted, very grateful to our head of the department, Dr. Bharti Ganesh, who has been a great supporter for me. And she is the one who told me that I should make a presentation on this disaster management and the smart cities. And therefore, that is the reason I am here making this presentation to you. And my sincere thanks to Dr. Bharti Ganesh also. And my thanks to all of you for patiently listening to me. And thanks a lot. Bye.
Okay, before we thank our speaker, we'll take up some of the questions posted by our participants. The first question is from Dr. G. Rajsekhar sir. His question is, can smart city proposals include any reclamation of land?
Again, your question needs further explanation. Again, it's all up to the government of India. They go through the proposal. In what way reclamation, for example, you take the city of Mumbai. Is that reclamation of land really necessary? And that is what you have ended up, what you are seeing today is more and more land is reclaimed for commercial purposes. For what purpose you are reclaiming the land? I am giving you another scenario. In Tamil Nadu and in some coastal areas, you try to reclaim land, grow mangrove forest. Such reclamation has sense. Why do you want to reclaim land to increase urbanization? Is it really necessary? I mean, of course, finally, when it comes to your question of whether reclamation of land, that would be included in the proposal of smart cities, that is up to Government of India when they see your proposal. But the way I look at it is unnecessary reclamation of land. Why it is necessary? What is the purpose? I would say no. For commercial purposes, I would say no. For the purposes of increased forest area, I would say yes. For environmental reasons, I would say yes.
Yeah, we have one more question from Dr. G. Rajsekhar sir. The question is, sir, any comparison made on Fukushima rebuild and the other disasters in India? Made on Fukushima rebuild and the other disasters in India.
Right now, I am not able to answer. I am sorry. No.
Okay. Any other questions from the participants? Fine. Now I'll take this opportunity to thank Dr. G. Raghav sir. The talk was a very deep, explicit, encyclopedic, realistic talk, throwing a light on the smartness of our cities and our preparedness for my co-host. Now, over to the next session. My co-host, Maulya, will be welcoming us to Maulya, madam.
Thank you, Meenakshi sir. And good afternoon to all the participants and esteemed guests. Department of Civil Engineering, NMIT. It is my privilege to introduce Dr. V. Ramchandra. He is a BE Civil Engineering from the University Visvesvaraya College of Engineering, UVC, Bangalore, and MTech in Marine Structure from NIT Surathkal, PhD in Structural Engineering from the Bangalore University. And he was a faculty at SIT Tumakuru for 18 years before joining UltraTech Cement Limited as Zonal Head, Tech Services in 2005. Some initiatives for construction industry is ICI UltraTech Awards for Outstanding Engineers and Structurals awarded every year at Bangalore, Mangalore, Hyderabad, Hubli and Goa. And Mason training and certification programs on large scale. Also the technological demonstration project on white topping in Bangalore and Chennai and Hyderabad. And alternative technologies for mass housing projects. And the association with the professional organization and academic institutions are the former Vice President, Indian Concrete Institute, and member academic council in several autonomous institutions, and member of Board of Studies, Civil Engineering in various universities or institutions, and member handbook on precast concrete construction in ICI. And he is currently the joint president and head tech services in UltraTech Cement Limited, Mumbai. And he is a member Civil Engineering Division Council, Bureau of Indian Standard BSI, that is BSI in New Delhi. And he is also the member H3 and H9 committees and also Indian Road Concrete in New Delhi. Once again, thank you for all the participants, and over to you, sir.
Sir, please unmute yourself and go ahead. Sir, not audible, sir, please.
Hello, hello.
Yes, sir, you are audible. Yes, sir.
Whether
Yes, sir, visible. You can go ahead, sir. Yes, sir.
Yeah. Thanks for the nice introduction, and it is my pleasure to join this at NMIT. And because we slightly exceeded our time, I'll try to save on time as much as possible, so that would mean that in terms of time also will be sustainable. The topic of today's presentation is on smart options, which are also sustainable as far as housing and roads. Let us quickly get on to the first one. What is the context today when we talk of housing? I am sure all of you must be aware of the declaration of Prime Minister that 2019-20 was what did happen that year? Maybe what actually happened during that 2019 was a construction technology year. He also organized, the government of India also organized Expo conference under this Global Housing Technology Challenge. This and I was fortunate to take part in that. Since he was a minister, and this challenge, this Global Housing Technology Challenge, was for alternative and proven technology, other than the normal technologies that are used for housing, and they should be cost effective in construction and it affordable housing, particularly the housing in urban areas. And it should be other than these two well-known technologies, namely load-bearing mason technology and RC beams, slab from infilled with masonry technology. That is because it was these are taking a long time, and therefore was the essence of this whole thing. Several technologies were presented, and out of this, some 6 projects were selected in July 2019. These projects were called projects or LHPs. What is LHPs? Lighthouse projects or LSPs. It involves construction of 1,000 houses in 6 locations, namely in Ranchi, Agartala, and Lucknow. These are the chosen 6 places, and the total target in the next years is to construct 2 crore houses. These 2 crore houses can be constructed using any of the technologies that are utilized in the construction of 1,000 houses each in these 6 cities. Technologies that were finally selected, and involved house of roughly about 400 square feet area. That is the one of those. These are the technologies that were adopted. For Indore in Madhya Pradesh, 1,024 houses using the prefabricated sandwich panel system. It is different than the brick and mortar construction that we think of. It is a sandwich panel system, cast and brought and assembled. Whereas for Rajkot, monolithic concrete construction has been approved with 144. I mean, the number is there in last call. All of them 1,000, in the range of 1,000. For Chennai, precast concrete, precast assembled at site. That is the normal way of our precast construction. 2-dimensional precasting. Many housing projects have been constructed in here, and this technology has been finalized for Chennai. And for Ranchi, it is the precast construction, but using 3D precasting or volumetric precasting. And for Agla, light gauge steel structural systems and pre-engineered structural systems. Now, for technology is slightly modified than this second one, monolithic concrete construction. It is called a stay-in-place formwork technology. Now, out of these technologies, other than the first and the third, very normal, regular ways of construction, I will be dealing number 1, monolithic construction, followed by 3D precasting, light gauge system, and lastly, stay in place. Another reason why I have the four construction technologies, we were involved in these constructions. Several houses have been constructed using this technology. Therefore, this technology it is used to be adopted. Now, what are salient features of this lighthouse projects? The construction is 12. This 12 months, please note, it is for the house construction. It is for the construction of 1,000 houses plus roads plus water supply plus drainage, rainwater harvesting, solar lighting, electrification, etc. All that ready to hand over stage it should be. And the housing design should be as per NBC National Building Code 2016. And there is incentive for early completion. If if the contract is completed before 12 months at $2,000 per month, about say 1.5 lakhs, 1.5 lakhs for incentive is given if 1 month early, and if you can complete 2 months before, double that. And these projects are as live laboratories for institutions like NMIT for transfer of technology, planning, design, production of components, etc., construction practice, testing, quality control. And for all the faculty members of all technical institutions, builders, professionals, both private sector and public sector. This is being offered as a live during these 12 months. They can go and they can interact with the engineers and learn about. And this very latest, just a few days before, 4 days before, Prime Minister India, Mr. Narendra Modi, inaugurated or opened this project, and construction is going to start from the 1st of March. From last year to this year, this project got delayed because of COVID, but now the funding is also provided, and this will go ahead quite fast. So this is of the new technology. On the right hand is a 3D plan of each one of this house. It has one living room, or in this case, 440 square foot is one particular place. It has one closet. That is the three-dimensional plan of this. Now, let's come to the first technology, which is called as the monolithic construction. In fact, the basics of this monolithic construction is prepared by the BMTPC, Building Materials Technology Council, and these houses built under Prime Minister's Awas Yojana. It is for urban settlements. As a separate design is for rural. There, it is not mass housing, multi-storied buildings. There, it is going to be individual houses in rural areas. Now, this involves the use of aluminum and foam concrete. Now, this is a development and of concrete that you aluminum formwork also is very as you know, lot of time we spend in plastering the wall. Now, because this provides a very smooth plastering inside and outside, no plastering is required. Now, a typical plan of 12 floor. This was executed in Gujarat a few years back. All these walls are 100 mm inches thick walls, and the roof slab is 5 inches. That is the thickness of the roof slab, and the entire structure is cast in situ reinforced concrete. The entire wall and roof is concrete. Now, if there are concerns about the walls conducting so much thermal conductivity, then the answer is to go in what is called as foam concrete. Thermal comfort. This is a plan for each one of these house, and you can see can be erected within a day. I would say within a day you can erect this. With is easy to erect, and it is light in weight also. And once you complete one floor, the whole formwork can be lifted to the next floor, and you can go on constructing. Formwork is the plastic form. Somehow it started by making this, but later on somehow it did not become very popular. Now, in piece of concrete, I will only touch upon this concrete. Foam concrete is produced. It is a lightweight concrete, very similar to normal concrete that all aggregates and water. But additional materials like fly ash or GGBS or metakaolin becomes a bit expensive, but GGBS and fly ash helps in reducing the cost. Now, what materials? As I said, constituents of the base mix is there. As I said earlier, concrete and foam. This foam using the density of concrete, unit weight of concrete, and it will better thermal activity. Now, you can use either you can add fly ash or GGBS up to 50 or up to 70% of GGBS as cement replacement you can add. Please note, strength is not a very primary requirement in this. After all, the strength parameter that you are looking for is hardly 15 MPa, which replaces whereas normal, roof will be M20, M25. Therefore, the use of fly ash can always be done. Making of the foam, this foam generator that can air pressure, and you can pump this foam to the concrete. Even in a truck, RMC truck mixer, foam making unit, so that while moving, it will mix the foam with concrete and blend it properly. And applications of foam concrete, trench filling. Yeah, you can see here, it's very light. Myself says it is very easy to pump. Now, this is the housing structure that I was referring to. This was 4 floors or 4 stories. It was constructed in 16 days. The rate of 4 days per story. And every 4 days, 1 story was completed, and in 16 days, the entire structure was completed. But of course, it took some more time, another 15-20 days for flooring, electrification. You will appreciate that constructing a ground plus 3 building in 1.5 months' time is definitely a great achievement. As I said earlier, you need not have plaster because the outside face and the inside face, it is quite smooth. It doesn't require plaster. This work starts aluminum shuttering. Now, same thing can be done case also. Now, this is the story of a village near Haveri, where we started executing this. That was in the year 2012. The then Karnataka government decided to build several hundreds of houses in that area, and they wanted a new technology. We adopted this monolithic concrete technology, and overnight shifted the aluminum form required for this from Bangalore to that village. Now, this is the day 1 foundation. Day 2 was the lean concrete foundation that was laid. Day 3, the plinth was laid. Day 4, single layer reinforcement for walls, normal regular reinforcement for roof, that was laid, because about 350 square feet at that time, it could be completed in less than 1 day. The whole thing. The same 4th day, we could pump concrete. We brought concrete from Hubli RMC, and you can see pumping of concrete that is going on. Concrete is pumped to the walls as well as. Please note, this concrete is designed for 1 day strength. When it's designed for 1 day, whatever strength it attains in 1 day, you can remove the shuttering after 1 day. Therefore, 5th day, the side shuttering is removed, whereas the vertical props are kept for 1 more day. So, 5th day, this was ready. And the 6th day, 1 coat of paint on the 6th day. 7th day, the Chief Minister was supposed to come. He came on this. Mr. Shettar was the Chief Minister. He said, I have come here to lay the foundation stone for several hundreds of houses. But what is this? I am seeing within 1 week, 100. Initially, he said, look, I will lay the foundation, but this new house you inaugurate. But then, a Chief Minister, being a Chief Minister, we request to open it. And for adopting this technology, Ultratech was awarded the CA award in the year 2013. After this, lots of houses using this technology have come up in different states, and the same technology is now being used for this another view, row of houses. Technology is only for single houses and poor man's house. Even for multi-storied structures, and from Bangalore city, when you are going towards NMIT, you do find some structures which adopted this particular technology. This is what L&T has in the Serene County building in Hyderabad, and the finished building looks like this, very beautiful and a very good one. Now,
Sorry
to
to
this
disturb you,
technology,
sir.
which
Sir.
we did, BBHC.
Sir, excuse me, sir.
Tell me.
Sir, I think the slide is not changing. I think it's the 26th one, sir. Slide number.
Seeing VBH.
First day, something like that.
Okay, I think.
Yeah.
Okay. Now, are you seeing second day?
And no, not yet, sir.
You are still seeing the first.
And the voice is also breaking, sir. Yes, sir. Yes, sir. I think
One
you
second,
can close the
one
presentation once again if you start. I think it will. Yeah, yes, sir.
Second, maybe I will also time connection.
Yes, sir. Yes, sir.
Okay. Just
Yes, sir. Take your own time, sir.
are you now able to see the third day?
No, sir. Not yet, sir.
You are still in the first day.
Yeah. Now you fourth day, third day. Yes, sir. Now it's changing, sir. Yes, sir. I think network is also good now.
Okay. I
Yes,
think
fine,
I changed the network from my end also. Okay.
Yeah,
I think this is what I was telling. Second day was the foundation. Third day was up to the plinth. Fourth day was aluminum shuttering, and one layer of reinforcement was done. Fifth day concrete was. Fourth day evening concrete was pumped. This is the fifth day, and sixth day. I hope you are able to see the slides now, right?
Yes, sir. Perfectly fine, sir.
Okay, and that is great. Now, yeah, I think I'll go slightly faster. Now, let me go to this VBHC project in Bangalore, Value Built Housing project in Bangalore, where we made one more addition to this technology. Aluminum shuttering, yes, foam concrete and aluminum shuttering. Plus, we also used a sensor. We used a maturity meter, wireless maturity meter system. Now, with the help of this, what we did was we just dumped sensors at different locations while concreting. Now, these sensors, it measures the maturity of concrete, which is related to the strength of concrete. You can know the in situ strength of concrete. Therefore, when will you de-shutter, you can decide based on this. Now, it works on the wireless system, very similar to our smartphones, and you can get the readings for sitting in your office or at home also, because it is anyway connected. And in this case, instead of 1 day strength, we could see that the strength was achieved within 15 to 16 hours. When the strength was achieved, we were able to de-shutter within 24 hours. That was the advancement in this particular project. Now, after this monolithic construction, let us now go to 3D precast construction system that is adopted in another place. The first technology is going to be adopted in Rajkot, whereas this is going to be adopted in Ranchi. A very similar technology. In fact, Bangalore has adopted this technology. Some of you may be already aware of this. BDA Development Authority has constructed houses using this 3D cast concrete construction. It is on Tumkur Road. You have to take a deviation. There it is. This is the BDA housing project 3 precast technology. Now they have built 1,520 units, very similar to this new venture, and it involves setting up of a factory very close to the site. Now, similar to a two-wheeler factory or a four-wheeler factory which manufactures your house. Now, your house is manufactured not a dimensional thing, but a three-dimensional thing. It is manufactured here, and this string is done, welding is done, everything finished, including fixing of tiles and electrification. Everything is done at the plant. Now, please, this is not at the site. This is at the plant, and even bathroom connections are also. When the site, parallelly, the substructure, the work is going on with precast blocks that are placed. Therefore, this is a unique thing. Substructure work is going on at the site. Superstructure is work is going on at the factory. Both of them are simultaneously being done. And once the foundation is ready, piece by piece, about 150 200 square feet each, this piece by piece, it is transported from the factory to the site. It is lifted and placed, and this is how the house is made. And similarly, staircases are also made this. They are fitted within 2 to 3 hours. You can get, you can finish it to this kind of accuracy. Therefore, this is the 3D precasting that is done, and this is technology that is being adopted for Ranchi. Now, the construction will be very fast. There are some challenges here. The challenges are whenever you are fixing a one precasting unit on the other, the joints are very important in case of casting. So what kind of grouts you put at the joints, non-shrink grouts, different varieties of grouts were tried out, and that also took some time. This was expected to be over in 2 months' time. It took slightly more time, 3-4 months it took. But remember, 1,500 houses, building it in 3 to 4 months' time, it is the most welcome thing. Now, this is the completed, the finished block, which you can definitely see. This is very close to Bangalore on Tumkur Road. This is the same technology that is approved and adopted and now opened by the Prime Minister. The third technology which is approved for Agartala, it makes use of light gauge steel, structural steel and concrete system. Friends, maybe you will feel happy to know that this also has its origin to Bangalore. There is RV TIFAC that is there in Kengeri. Dr. Gopalan is a scientist head of that. He is an expert in this light gauge structural steel, and we have worked very closely with him. He was an expert on steel, and Ultratech joined him in providing foam concrete to this, and therefore this light gauge structural system concrete steel, that project has come up. Now, what does it consist of? It is a light gauge structural steel, 0.76 mm thickness. Now, this entire thing is made out of steel, light gauge steel. Now, this house is completed, and whatever the walls that you need to fix, we put foam concrete into that. We put shuttering and put foam concrete into. Now, foam concrete is being prepared, as you can see here, and this is how the light gauge system in the plant that is done. Now, these are some photographs of construction. Plinth and foundation is constructed in the usual way. The second is the erection of light gauge structure and fixing of cement fiber board. This cement fiber board acts as a shuttering. Now, earlier you saw shuttering. Now, here it is a cement board shuttering. Now, this cement board shuttering is placed on either side, and concrete, foam concrete is poured. and therefore the house is made. And the electrical and sanitary fittings are all inserted during the construction of this light steel, and they are all very nicely embedded. It is very easy to work with that. And this is the completed house that is being painted. And this house of ground plus one, it was constructed for the Karnataka State Police Housing Corporation using RVFAC and Ultratech jointly work together. This is the finished house that you can see. Friends, you will agree with me that when you are constructing a new, with a new technology, when you are constructing a house for police, you have to be very careful. The technology should work. Therefore, after that, we used to visit this place in Adugodi quite frequently to see if there are any problems they are facing or any cracks or whatever. No such thing has happened, and this technology has worked quite well. And this is a technology that is adopted as one of the lighthouse projects. This is the third technology. Now, the fourth technology is a stay-in-place formwork. This is adopted for Lucknow. Now, very fortunately, one such experiment with that has happened in Bangalore. Earlier, it has this has been practiced in Maharashtra in some place, and we had one project on Kanakpur Road where we were also involved. Now, compared to aluminum shuttering, this is a cement composite board. This is how called as a stay-in-place formwork, and a stay-in-place formwork means the cement composite boards are placed on either side, and concrete is poured inside this. Now you can see this. Yes, this is a cement board. Once concrete is poured into this, the boards also will stay in the same place. You are not going to remove shuttering. That is why it is called as the stay-in-place formwork. Now ground floor is over. Same thing with, and bars, reinforcing bars, a reinforcement cage is provided, and just bars are just inserted, and that will take care of the wall reinforcement. Now you can see here how the main bars and distribution bars are provided for the wall. And this is the completed house. This is the completed house. This was completed in about 1.5 months time. Please note, 1.5 months, not just for the construction, including painting, including fit everything, and hand over the keys to the owners of the building. It took about 1.5 months. Is a great advantage, right? Of time, this will be a great advantage. Now, I must tell you, this will happen only if our workers are multi-skilled. Can't have masons separately, carpenters separately, painters separately, plumbers separately, and electricians separately. There was a gang, it was a labor gang which was working here, who were all in one. There were 10 people, 10 multi-skilled laborers. They were only the shuttering experts. They were the electricians, they were plumbers, they were carpenters, they were all one. Even fixing the latches, etc., everything they did, or they knew where they are required and when they are required. That is how the speed was achieved in this particular place. So this is what I thought I would share with you. I am sure you would agree that all these four technologies are quite fit for this lighthouse projects. And these are the four technologies that are coming up. Now, because they are coming up in the next year, you will have the opportunity to visit them and learn a lot from these constructions. Now, let us quickly go to the roads. On roads, maybe I'll try to go a bit faster. I hope, Professor, my slides are moving normally, right?
Yes, sir. Yes, sir.
Okay, that's great.
Going good.
Yeah. Now, okay, I thought it is duty to acknowledge the people who are responsible for this, for updating me on roads. Even while teaching, I was not I did not have any expertise on roads or concrete roads. It was Dr. L.R. Kadiyali who initiated me into this. and lot of interactions with CRRI. And being a committee member of Indian Roads Congress, I had an excellent opportunity to interact. And of course, my team, Ultratech, they have done a lot of groundwork in executing many of these road projects in different places. Now, I'll go fast. I don't have to show you this. What constitutes a good road? It is the serviceability, it is the durability, it is the cost effectiveness, and ruled in 2015 that roads is a part of fundamental rights of a citizen. Now, if Bangalore roads are not good, you can go to court and you can demand that it is my fundamental right to have good roads. These are the pavement types that all of you have studied from the transportation engineering. Flexible pavements, bituminous, concrete pavements or rigid pavements, composite pavements, maybe bitumen on concrete or concrete on bitumen. It is called as composite pavement. And ICP stands for interlocking concrete paver blocks. Such roads are very popular in Mumbai, but unfortunately Bangalore has not adopted paver block roads very extensively. Anyway, I'm not going to discuss about interlocking paver block roads. Now, so far we are adopting flexible pavements because earlier it was that whatever money you require for 1 kilometer of concrete road, you can construct 2.5 kilometers of bituminous road. Therefore, lack of funds was an issue. Now that is not the case. Cost of construction of 1 kilometer of concrete road is equal to the cost of construction of 1 kilometer of new bituminous roads. And in case of bitumen roads, amenability for stage construction, the top layer you could construct in different points of time, whereas concrete road, you can't do that. You can't construct 2 inches this year, 2 inches next year. You have to continue as per the design. And in case you make mistakes, you can't correct it in concrete. You should make a good concrete road. Shortage of cement, of course, earlier days, now it is not there. And particularly this mechanization in concrete production and paving machines, that is playing an important role. Now, I have taken example of soil CBR of 5, traffic of 150 million standard axles, that is a heavy vehicle traffic, 2-lane. And I have designed this flexible pavement as per IRC 37 and rigid pavement as per IRC 50. Now, this is the layer that you will get. Flexible pavement or bitumen pavement, you will get it as a total thickness 770 millimeters. It consists of the drainage layer, granular subbase, WMM, DBM, and finally bitumen concrete. Whereas you go for concrete pavements, totally it will consist of 600 millimeters, drainage layer, dryling concrete, and pavement quality concrete, which is M40 or M45 grade of concrete. Now, let us not look into the aspects here because we are focusing more on the sustainability aspects. Now, this chart, Venn diagram of sustainability, you are all aware. When it comes to construction, the second diagram is widely used. Any technology that you should adopt, you want to adopt, it should technically it should be a possible. It should be a possibility. Adoption, practicality in adoption, that should be there, and commercial feasibility. Suppose a technology is technically good and it can be adopted also, but if it is commercially not feasible, if it is going to be very expensive, then nobody will adopt. Only when all the technical, adoption, and commercial, all the three are satisfied, it becomes a sustainable project or a technology. Now, let us compare the sustainability of these two different types of pavements, that is bitumen pavement. Now, if you take a 20 period as a standard period, concrete road, if you construct now 20 years, there is no maintenance, whereas bitumen roads, as per IRC, every 5 years, you are supposed to put an overlay. Actually, every 5 years, but generally every 2 years, 3 years, the quality goes and we put one more layer. Now, periodic renewal requires stone aggregates per kilometer. Two lane means 3.5 plus 3.57 meter wide, 1 kilometer in length. You require 4,150 cubic meters of aggregate every 5 years. Multiplied by 4, you will get total 20,000 cubic meter per kilometer. Whereas concrete pavements don't require aggregates at all. Where bitumen is definitely an imported one, whereas concrete or cement is not an imported. This is a very old, very cartoon in Times of India. Now that time Dr. Manmohan Singh was the prime, and somebody is telling. I asked him. He says he is getting prepared for the future, because if petrol and diesel, it is supposed to be available for the next 15-20 years only, and this man is preparing for the next state when petrol and diesel are not available. If petrol and diesel is not available, then it will create a big problem for us. But also please note, when petrol and diesel are not available, bitumen also will not be available, because bitumen is one of the extracts of petroleum extraction. Now, I don't know, maybe whether you are able to read these two bar charts. The first bar chart is from, I mean, all these statistics are what I am giving you is from the Ministry of Road Transport and Highways. Now, the number of accidents in the year 2013 was analyzed. Out of the total number of accidents, the third most important thing that was responsible for accidents was the defect in road construction. And as you can see, out of that, potholes in the second graph, you can see potholes caused 6,400 people to die, which means 6 people die, get injured every day due to potholes. And where you see the maximum number of potholes, you can see this photograph. Potholes normally seen after a rainy season on all bituminous roads. Bituminous roads are very susceptible for potholes, and very frequently the roads go bad, and that is a share of various states. Okay. Not yeah. Now, as you can see in this flexible pavements and rigid pavements, there are large deflections. When a wheel load moves on a flexible pavement, the deflections are large compared to rigid pavement, and thus it consumes more fuel. And these have shown that fuel consumption on in heavy vehicles on bitumen roads is 10 to 15% more. On concrete roads, it is 10 to 15% less. Now, this is the statistics from the Central Research Institute. I am quoting it from the report of CR. Now, this road transport accounts for 77% of consumed in the transport sector, that you are already aware of, and more fuel is required for heavy vehicles on bitumen roads compared to concrete roads, because the deflections are more in case of bitumen roads. Now, this is a study that is done on the use of bitumen concrete. Now, during construction and during its maintenance, during its lifetime of 20 years, this study has been done by CRRI. That is about 10-12 years back. This has been done, and you can see the last row, 25 truck, 25. It consumes a fuel of 432.4 cc per kilometer of travel if it is concrete, and 510 if it is on asphalt. Therefore, there is a saving of 15% of fuel on concrete roads if it is a 25 ton truck. Otherwise, on an average, you can see that the average saving of fuel is about 10%. Therefore, that contributes to sustainability. Now, not only during its lifetime, during its construction also, are now the total energy that is the total fuel that is consumed in asphalt, because you'll have to heat that and then use it. That also contributes to quite a bit. 1190 crores and 751 crores. This is the statistics for 100 kilometers of 4-laning of roads. This is the saving that you get. Now, in case of concrete roads, the road emissions are also less because fuel saving is definitely there. The carbon dioxide emission is less, nitrates and SO2 emission also less in this. Now, you all agree that when light is reflecting on a road surface, surfaces don't reflect light so much. If it is a light surface, that is albedo, it reflects much better light. That means you need not have so much of lighting on the roads if you build a concrete road compared to bituminous road. Therefore, cost of lighting, it is supposed to be about 30% saving in the initial energy and maintenance cost. Now, even the braking distance is much compared to dry concrete road and dry asphalt road. For example, dry concrete road, it will take about 162 feet, whereas dry asphalt road, it takes 190 feet. That is the braking distance. Therefore, braking distance is much better. That also adds to the heat island effect. Now, you don't have to conduct a research to find out this. You walk barefoot on a summer day at 40-degree temperature. You walk barefoot on a concrete road and on a bituminous road. Probably your legs will tell you what is absorbing more heat. And for it is compared to bitumen, concrete is definitely much more eco-friendly because there is a lesser energy footprint. There is also a reusability. After 20 years, concrete can definitely be reused. Recycling of concrete can always be done at the end of its lifetime of 20 or 25 years. Now, this is the rating given by LEED. All of you are aware of LEED rating, Leadership in Energy and Environmental Design. LEED has rated concrete roads with a marks of 61. It has scored 61 marks compared to 30 marks in case of asphalt road. And therefore, LEED has declared that asphalt overlay is not green and concrete is classified as intermediate green. I mean, in the interest of time, I am slightly going faster. Maybe I can share this. You can go through that in greater detail. And you are all aware that supplementary cementitious materials can be used, and that will further reduce a carbon footprint of concrete. But let me tell you, there are few issues. In India, we are all very fond of digging roads. Today you lay the new road, tomorrow some will come, electricity or whoever, they will come and dig the road. That is a problem with concrete road. You can't allow digging, and digging is also not easier. And another minor issue is that people say that when you are driving on concrete roads, there is a noise. That is true. There is a slightly increased noise, but in India, where this you may not notice at all sometimes. Now, to address this, what should be done? Now, avoid digging. What is done in Mumbai, Pune, and other places also, in Bangalore also, that every say 50 meters, 100 meters, they put a cross duct. If you are instead of cutting or digging, you should take your utility on the shoulders and go through this cross ducts to cross the road. You can't cut the roads. Any OA cable or anything you want to lay, you should take it cables to the other side of the road. You can't cut it. That is how you can avoid this. Now, these are some of the roads that you can also see the shoulder. Yeah. Now you can see the shoulder where these ducts are provided at regular intervals. That is also seen there. And even in a road, it can be done. You can see the location of ducts also in this small road, right? So these are some of the things I wanted to share with you. Yeah, this is another way of providing ducts. These steel plates can be removed and you can access the ducts at regular intervals instead of cutting the road. But friends, I must tell you that when you are constructing, when you are doing any work with concrete construction, quality is the important thing because concrete is an unforgiving material. Quality of concrete roads is best understood by looking at the distress. There are certain distresses that are observed, cracks that are observed, and we should precautions. In case it comes still, there are remedies that are available. Therefore, we cannot tolerate any deficiency in design or material construction. It will definitely go in the form of cracks and structural failure. But if distress is noticed, correction techniques are available, lot of grouts are available, and a lot of codes in recent times. I should tell you that Indian Roads Congress has been very active and it has revised almost all codes related to concrete roads. Indian flexible roads pavements as well as concrete pavements they have revised. And the last one, what you are seeing, IRC SP 83. I was fortunate to head the team for the revision of this particular code, repair, rehabilitation, and maintenance of concrete, cement concrete. And the design guidelines for our IRC 58 for normal roads, and for low volume traffic roads, it is SP 62. Now, last maybe one or two slides. This is the pavement quality concrete requirement. You need to have M40, M45 grade. Slump is not the criteria. Depends on whether you are using a fixed form paver or a slip form paver. And use of super plasticizer will become essential. Use of fibers will help in reducing cracks. Now, the last thing that I want to show you is about a new technology called precast concrete pavements. Precast concrete pavements is an Indian experience. We were talking about it for 10 years back. Dr. Alfred E. had come from Singapore. He has a patent on precast concrete pavements. In fact, he taught us several concrete pavements, but unfortunately, we were not able to execute it within his lifetime. But now, here, we have been able to join hands with a precasting unit in Nagpur, and we have been able to make the first precast concrete pavement. That the design was done by VNIT Nagpur, the NIT Nagpur. They were responsible for the design, and the precasting was done by a very excellent entrepreneur, Mr. Milind Digraskar. And these panels you can see on the right hand side, panels are being completed, and it's a busy. Panels are laid, and the finished road is there. So this is the comparison. 3.5 by 2.75 meter panels, 200 diameter, 200 mm thickness, 25 mm diameter well bars, and curing it was not required because it is already cured. These are the comparative things as far as precast concrete pavements is concerned. I want to share with you that Bangalore also will shortly get a precast concrete pavements. We are in discussion with BBMP, and they have shown a lot of interest. And Professor B.R.S. Murthy, former professor of Indian Institute of Science, he is also actively participating in this. It is our fortune. Concrete precast road will come up Bangalore. Therefore, as a concluding remark, I wish to tell you that concrete can help, whether it is house or road. It can definitely be a good more structural product and a sustainable product. We have seen how sustainable it is. And concrete is a democratic material. Anyone can participate. That is what is happening in our country. It endures. It is also tolerant, like democracy. Like democracy, it is mostly used, sometimes misused, and sometimes it is abused, and therefore you see some failures. And this is one important thing, it is unforgiving. Therefore, we must make a good concrete house or a road, and it will give an excellent service for a very long time. Friends, I think with this, I'll end my presentation. If there are any quick questions I can take, I would leave it to over to the organizers now.
Hello, sir. We have a. The question is, what radius does the apparatus cover? I think, sir, Dr. Jiraksik, sir, I think, can you be more specific about this question? The question is, what radius does the apparatus cover?
You was mentioned.
What is it?
Hello.
The question is, what radius does the apparatus cover? I think it's regarding the sensors.
That is a sensor. Okay. It doesn't cover a very large radius. Hardly, I would say it can replace very similar to our cube. 150 by 150 by 150 is our cube strength. Maybe we can assume that this also presents strength of concrete in a very limited area, 100, 150 millimeters. Therefore, the number of sensors that you would require are quite a few in a wall, and overall strength reading from all these sensors that will give you an average strength of concrete in the structure.
Okay. So the next question, it is question from Vignesh Bharti. The question is it similar to prefabricated construction?
What is similar to prefabricated construction? What is it that he's
Vignesh sir, Vignesh Bharti, please be specific, sir. We'll move on to next question meanwhile. So the next question is, how the grouting can economize the design versatility?
How grouting can economize? Okay. Do one thing. Please make a list of these questions. Please make a list of these questions and please send it across to me. I will answer all these questions, and you can circulate it to every member. Whoever has asked, it is not that go only to that person. A list of questions and answers can go to everybody.
Sure. Now I'll request Bharti.
I am only worried about my next speaker, Dr. Ajit Sabnis, who must be already waiting there. Therefore, I'll leave the space to him. Thank you very much.
Thank you, Dr. V. Ramchandra sir. During yesterday's presentation, Dr. D.R. Ravi, Environmental Officer from Karnataka State Pollution Control Board, he mentioned that make the life sustainable and then introduce smartness. And our Professor NRS sir, advisor of Nitte Meenakshi Institute of Technology, was insisting on taking less privileged group forward in the process of making cities smart. During your presentation, Dr. Ravi Ramachandra, Vice President and Functional Head of Ultratech Cement Limited, he took us through various initiatives by Government of India towards Prime Minister Gram Sadak Yojana, Housing for All, or Skill India initiatives, or so much more schemes which have been introduced by present government. I think the bottom-up approach of smart cityness is most suitable for most of Indian cities. Smart city group consultant should certainly look for such options in the process of making the smart city. Thank you for your wonderful presentation, sir. Thank you.
Thank you very much.
I welcome Dr. Ajit Sabnis. For the next presentation, over to Uma Shankar, Assistant Professor, please.
Okay, I take this opportunity to welcome Dr. Ajit Sabnis sir for this next session. Okay, a small introduction to the speaker. He has completed Bachelor of Engineering in Civil Engineering from Bangalore in 1979. He has completed his Master's in Engineering Mechanics from IIT Madras, India in 1981. He completed his PhD from Jain University, Bangalore in January 2017. His thesis title was Sustainability Evaluation of Construction Materials and Buildings. Talking about his professional experience, he has overall 39 years in the field of civil engineering. He has worked for Gammon India, K. Raheja Development Corporation. From 1991 till date, he has established NCCON AG, an innovative civil engineering conclave. It has completed a number of projects of 350 plus, ranging from residential to industrial projects. He has also contributed content for Karnataka Civil Engineers Handbook, published by Task Force Government of Karnataka, India. Some of the major projects that he has involved are Grain Silos, North Africa, Navashiva Port Project, Mumbai, Ganga Bridge, Patna, Raheja Arcade, Bangalore, establishing Precast Yard for Grain Silos at Mumbai, Buddha Museum, Sannati, India, underpass for Indian Air Force using box push technology, Bangalore, using PEMB, Precast Technologies, India, pharmaceutical, residential, and hospital buildings at various locations, India, SPI City, Software Park, Mysore, India, Worth Electronics, Mysore, India, SDM, Mysore, India, Ayurveda College Campus, Hassan, India, Low Energy Building Project using Earth Technology at Tamil Nadu, India. Currently, he is a founding partner in Engineering Conclave, founding partner in INSEE Retrofit and Structural Rehabilitation, past president, Association of Consulting Civil Engineers, India, principal consultant, ASP, SDA Sustainability Evaluation, member of TC 14 Committee, Asian Council for Civil Engineers, editor-in-chief, Build Constructions, an online reference magazine, chairman of a CBSE school, Bangalore. He is also a member of advisory board to consultant to a low energy project recognized by UNEP Pondicherry, Tamil Nadu, renovating heritage structures to their old glory. He is also a member of various professional affiliations like Association of Consulting Civil Engineers, Institution of Engineers, life member of Indian Concrete Institute, also a member of American Society of Civil Engineers. He has various awards to his credit: Best Editor-in-Chief, Construction Industry Magazine category, CIDC, Eminent Engineer from Association of Consulting Civil Engineers, ACCE, Award of Excellence at IIT Madras 1981, Certified Project Engineer in the field of Sustainability Assessment issued by Engineering Council of India, and Outstanding Concrete Engineer Award from Ultratech 2019. He has various publications to his credit. He has also guided more than 12 postgraduate graduate and 8 postgraduate students in their internship programs in the field of sustainability. Also, he has delivered various keynote address and technical talks at various locations, even in international conferences, including at Tokyo, Kuala Lumpur, Singapore, and Hanoi. I take this opportunity to welcome Ajit Sabnis, sir. A warm welcome to you, sir. Now over to Ajit, sir, for the presentation.
Yeah, thank you very much. Can I share my screen? Umesh?
Sure, sir.
Yes, sir, you can share.
Is that visible?
Yes, sir, it's visible. Go ahead, sir. Please go ahead.
Okay. Good evening, one and all. And at the outset, let me thank the organizers of NMIT, Bangalore, and in general, Faculty of Civil Engineering Department, and in specific, Professor Bharti and Dr. Raghav, who were in touch, and then giving me this opportunity to be a part of this and share some of the things which I know. It has been a wonderful learning experience myself because the topics chosen and the theme of the seminar itself is actually, I feel, the need of the hour. There have been excellent deliberations in the past 2 days, and it has been a great learning. And thank you, organizers, for this kind of a tremendous amount of informative dissemination of knowledge. Thank you very much. And thank you, Umesh, for that lovely words about the introduction. I think we will have to cut down these introductions henceforth because it's becoming too much. So I can use that small extra time to my talk. So let me begin my talk saying sorry, I think there are some messages which are popping up. A green approach to meet energy demands of smart cities. This is an excellent topic, actually. We have been listening to past, in 2 days, we have learned about what smart cities are, and then about the disaster management, and then several aspects of smart cities and how they go through, and then what kind of journey they go through. And then the last speaker, Dr. Ramchandra, also talked excellent information about how the housing and then road, how we can economize, optimize, and then make them more sustainable. All these aspects have been very well dealt with. I would like to start, and then this is the green approach to meet energy demands of a smart cities. Let me confess in the beginning itself, I am basically a civil engineer, and then probably hence my focus is in the framework of civil engineering. I may probably miss some of the very finer points which are related to the other disciplines, and because energy, is one subject where all disciplines get integrated. So my focus will be essentially with the civil engineering background. I would like to say that energy is the foundation of all advancements and then the progress we have witnessed it so far, we are witnessing right in the current era, and the progress what we are going to witness in the future. But it is also at the same time, energy is also the primary cause, one of the primary causes of all the crises we are witnessing in the present era. And there is also an important point where, especially with respect to the developing nations like India, where we have always we have this confusion or kind of a bias, whether should we go in for sustainability or should we go in for development. Obviously, for the developing economies, the development which is governed by the global agenda, what they call as 2030, in the framework of all the sustainability development goals, development, industrial development, improving, going higher and higher in the slabs of GDP, improving the annual or monthly income of the citizen, giving them good life. All these developments are also equally important. So especially for a developing nation, it becomes a confusing thing or a kind of a conundrum, which one to decide or which one to go in for. But at the present moment, since we are all globally connected, and since we have also committed to the global 2030 agenda, we need to act globally, we need to act collectively and face the crisis and the kind of problems we are facing because of the climate change and other sustainable indicators, impact indicators. So we need to take a look at them and then design, and the urban designers have to come into the picture, take all these things into consideration, and then we go ahead with transforming the existing cities into smart cities. So this is mainly the preamble. what I'm going to do is the entire presentation probably will be addressed in 3 parts. The first part probably is going to be what exactly, let us understand what exactly is green approach, which means to that what is the sustainability. And the next one is what exactly the smart cities. We have, of course, heard enough of what smart cities is, but I will briefly touch upon some of the core issues of the smart cities. And this all will be in the backdrop of energy demand for the smart city. And then we will also briefly go through the kind of mitigation strategy which we require in the smart cities, and also to optimize the energy demand in the smart cities. So that is how I would like to go through this. It is not necessary that the slide or the presentation will be in the same order. And there may be also a possibility, since many experts have spoken on the same subjects, there may be few slides which may be overlapping in terms of information. So I think both of us cannot help. So let us go through this presentation. Yeah. Now, very quickly, understanding sustainability. All have defined what sustainability is. I would not like to go the sustainability. What is very commonly defined is by the World Commission. But what is important is the National Building Code of 2016, Part 11, in approach to sustainability, defines sustainability as the state in which components of ecosystem and their function maintained for the present and future generation. Now, this is as per the National Building Code, which is recently is available to everybody. The fundamental tenets of sustainability, as we know, is reduce, reuse, and recycle. And then this, I think, these 3 parameters will get very intricately woven in all aspects of sustainability. Now, what makes city sustainable? What makes city sustainable is, sustainable cities are actually socially, politically, and culturally inclusive, economically productive, and environmentally stable. These are the 3 fundamental pillars: socio-cultural, then economic, environmental, all these issues which are there. Now, if we take one pillar one after the other, what becomes important is the sustainable cities which are founded on these 3 pillars. Actually, and then if we go into details, now economic productivity, which actually is in urban scenario, enhances when we have better infrastructure, better living, comfortable living, we have good connectivity, better amenities, good air to breathe, less pollution, better waste management. When all these things actually come into the picture, when all these things are made available, then the economic productivity will be very useful. And when these things fail, the cities usually get infested with a lot of crime, the violence, and they will also get congested and ultimately become non-livable. As far as the social inclusion is concerned, the cities should not become places of division between rich and poor, haves and have-nots. The cities should become places where all can interact and exchange without any barriers and participate in all activities very peacefully and proactively with trust and social mobility. This calls for effective policy decisions, good planning, keeping social equity in mind. And thirdly, the environment stability. By definition, cities are populated with high density, and hence they are vulnerable to the air pollution, rapid urbanization, and rapid spread of diseases, communicable diseases, environmental shocks, and so on. This is in the recent past 8 months, we have actually experienced this, how disease a great lesson has been taught by this pandemic, and how communicable diseases can spread so rapidly. And this has been, we have the example right in front of our eyes. Then we are also in for environmental shocks, especially in case of coastal cities where the development is comparatively higher as as we compare to the inland cities. The coastal line cities are comparatively better equipped to take in terms of development. And one of the environmental shock which these cities face is the high rise or the rise in the level of the ocean because of the global warming, etc. Now, how does the city respond to it? The city can respond to it in two ways. One is the adaptation to the impacts caused by the already locked in greenhouse gases. And second strategy would be evolve proper mitigation strategy to reduce their carbon footprint. Now, all these things we will see it in detail as we go ahead. Meanwhile, I just want to check, is everything audio and then slides are visible, sir?
Visible, sir. Visible, sir.
Okay, yeah. Please let me know in case there is anything is happening. Okay. Now, we all know that the genesis of the entire problem, entire climate change and the global warming, etc., as discussed earlier, quite few of these things, urbanization, the moving from rural areas to the urban areas. This is one of the biggest problem which is causing, and then hence the impact of climate change and the impact of global warming. All these things are felt higher in urban scenario. So if you look at it, this graph has been shown probably earlier also. Now, if you, in terms of percentage of urbanization by Asia, we'll have the red, the indicators are here. The indicators are, I'm showing it by the cursor. The indicators, the red one is actually by 2030, Asia will have an average percentage of urbanization to the tune of about 55%. Now, the world average will be about 61%. Asia in particular will be, and as compared to India, will have a 41%, which I think is going to be changed as per the 2020 consensus and then the extra data statistics. It may probably touch by 50% by 2030. And this whole thing, the phenomenal growth in urban population is for several reasons. And let us not get into, but one of the major issues for the urbanization actually is one of the major issues. Now, if you break this into rural and then urban population, and this is how the whole graph looks at it. This is as of 2017, where from the urban population will actually, this is the global number of people living in urban and rural areas. This is the global data. We will have more than almost nearing to 5 billion people will stay in the urban areas. The remaining 2 billion people will stay in the rural areas. So this is the extrapolation which was done in 2007. The graphs pertains to 2007, and there may be slightly variation as we look at it from 2020 point of view. Now, let us come to the smart city programs. Now, as I have been saying, we have all the national agenda, international agenda, the global agenda, the city agenda, all these agendas, the plans, the plan of development, whether even for example, including the smart city programs, everything is actually in the framework of this, what we call it as 2030 agenda, wherein all the sustainability development, 17 sustainability development goals, as you can see here, 1, 2, 3, 4, play an important role. But there is also a very pertinent goal, is the sustainability development goal number 11, which the theme which says that make cities and human settlements inclusive, safe, resilient, and sustainable. So this is where the smart picture come into the smart cities come into the picture. And in fact, this particular question of smart city and sustainability coming together encompass all these 16, 17 goals. Nearly, so only when a city which actually satisfies the themes of all the requirements and the criteria of all the 17 goals, then it becomes actually a perfect smart city, which is probably looks like an utopian condition, even with the developed nations. But then the government has taken several initiatives with respect to the smart, the goal number 11, which is the infrastructure development and smart cities development. Now, cities are engines of growth for the economy, and nearly 35% of this is we know. And what is important here, with increasing urbanization, urban areas are expected to house 70% of India's population and contribute to 75% of India's GDP by 2050. So almost about 70% of the population, Indian population, which is expected to be about 1.5 billion, 74% of it will be in urban areas, contributing to 75% of India's GDP. This requires comprehensive development of physical, institutional, social, and economic infrastructure. One of the important things is the entire smart city is not just building good infrastructure, aiming at optimization. It is not just that. What is important is all this infrastructure, because it involves human species and all the living organism, and it encompasses the entire ecosystem, and the entire built environment has to integrate with the natural environment. It doesn't become a static. It actually a very dynamic process in which everybody is involved. So transformation of a city from an ordinary 1 tier through 2 tier, 3 tier, or whatever tier city is, and transforming that particular city into a smart city is not an easy task. It is an extremely, it's a big Herculean task. So we need to consider it is dynamic because the human psychology is also involved in it. Now, we are witnessing unprecedented global events because of the global warming and increased carbon dioxide concentration. The rapidity with which the greenhouse gases emission is increasing, the rapidity with which the ocean acidification is happening, which has never happened in the last 3 million years, warming of ocean waters at 700 meters depth, rapidly changing rainfall patterns, accumulating waste, urbanization, rural migration, melting of glaciers, flood, all other anthropogenic calamities, polar amplification, and permafrost, etc. Dear friends, why am I saying, why are we, in what way the energy demand is related to these things? These actually are the indicators, and energy which involves the burning of all kinds of fuels is actually one of the primary factors which pumps in the greenhouse gases, majority of it. Now, because of the global warming, and which increases the global warming, the emission of greenhouse gases, the accumulation of greenhouse gases, which form kind of a blanket, increases the temperature, the global average temperature, and then this actually induces huge amount of climate change, which we are witnessing. Now, what exactly? There are several factors how the global warming or the climate change impacts. We see ocean acidification, eutrophication, habit fragmentation happens, forest fires and deforestation, soil erosion, water depletion, and several other impacts because of this climate change. And the genesis of this climate change, climate change, of course, has got several other important reasons, but the global warming essentially is due to the increase in greenhouse gas emissions by the human species. Now, when we talk about the increase in global warming and how to mitigate the global warming, we have two scenarios, which actually we call it as 1.5 degree scenario and then the 2 degree scenario. Now, this 1.5 degree scenario is the scenario where by 2100, we should not exceed, with the existing global average temperature, we cannot exceed beyond 1.5 degrees centigrade. Then what happens? And then the second scenario is when we exceed 2 degrees, what is going to happen? So because of those consequences, what happens if we exceed 2 degrees? What happens if we exceed 1.5 degrees? We need to take the steps much earlier than that to maintain and to limit ourselves below 1.5 degrees and below 2 degrees centigrade at the max. Now, from energy point of view, and from energy generation perspective, there are two main lines attracting the most attention. First, actually, is the renewable energy sources entailing a mid to long-term investment for energy self-sufficiency without compromising the future generations, and secondly, fossil fuel source. Eventually, it is important to note that the smart city should gradually migrate to full renewable energy schemes and the mechanisms. So this is in the graph, what you see, this red mark actually is if we do not take any action and keep going as of now what we are doing, then we will probably not be able to contain the global average rise to 1.5 or 2 degrees centigrade. We will be touching upon 4.2 to 4.5 degrees centigrade increase to the global average, and then which will actually cross increase much more the greenhouse gas emissions. Then we will probably touch the 500, we will touch the concentration, CO2 concentration to the levels of 500 or 525, which will be extremely damaging to the human species, or for that matter, all living organisms. Now, we have all those materials, which wherever the construction industry, as I said, I would like to limit in the built environment framework, because, and the construction industry contributes, consumes about 40% of the total energy, energy produced, and then it consumes also approximately 40% of the total energy consumed. So it's also responsible to the tune of about 35 to 40% emission of greenhouse gases. So hence, for all whatever are the constituents of the construction industry, to take them into consideration. And so when we take materials, when they classify materials based on energy intensity, we have certain materials. These are the things which can be actually seen from all the points. We have materials like aluminum, stainless steel, plastic, copper. These are actually, many of them are metals which fall under very high energy category. Cement, steel, glass, bitumen, don't bother about these numbers. They are some indicators. So then high energy, cement, steel, glass, bitumen, solvents, cardboard, paper, they all come under high energy. Medium energy, we have the regular conventional materials, including lime, gypsum, plasters, burnt clay, aerated blocks. Low energy, this is what is important. We have sand, aggregate, fly ash based products, cement stabilized products, etc. All these things we have the standard codes, and then where the information is also available to us. Now there are several indicators in the sustainability. To understand sustainability, there have been several indicators, and then in fact, United Nations Environment Program and United Nations Development Program, United Nations Framework for Climate Change, all these things talk about 500 plus indicators. So, and then there are several indices which I'm sure Professor Bharti would have touched upon, about the Living Planet Index and the Ecological Footprint Index, Human Development Index, Environmental Stability Index, Environmental Performance Index, and then there is also what is called a Happiness Index, which actually plays. So I will touch upon the Human Development Index and then Happiness Index in a short while, which actually is very, very important. But these indices are also taken into consideration while ranking the smart cities and other things. Now, let me touch upon Human Development Index. Now, it is not enough just to integrate the sustainability aspect and then make the city smart. smart. But what happens is whether the integration, by integrating these two areas, whether will it ultimately, why are we doing all these things? We want the human beings and other living species have to live comfortably. We need to be happy. We need to live long. We need to be healthy, isn't it? This is the final outcome. This is why we need to transform our cities into sustainable cities, into smart cities, and all those things. So, Human Development Index is that measure, of human development. This takes three key parameters into consideration. One is the long and healthy life and access to education, and then the decent standard of living. These are the three important parameters which the Human Development Index takes into consideration. In India, unfortunately, every city is not, we still do not have Human Development Index from city-wise, but we do have Human Development Index for state-wise. So India has got, for example, this is the one which talks about, it gives ranking of the Human Development Index, which actually Human Development Index varies between 0 and then 1. And then these are the various numbers which are available. So which actually you can see here. If I enlarge this, the writing is there. Now, for example, the one which you see red is actually less than 0.5. So that is the sustainability index, Human Development Index. And in this graph, when you see, what is important to see here is the Human Development Index may fall in the same range, but actually the per capita primary power consumption also varies. For example, India, if you take this zone, the Human Development Index may fall in the same bandwidth, but we have per capita power consumption is higher. So that is because of several other reasons. Usually there is a tendency that the developed nations consume more power, even though we have the same Human Development Index. So this is one part of it which actually plays an important role when transforming a city or from city to a smart city status. Now, other important thing here is the happiness index. Happiness index actually originates from Bhutan, and Bhutan is gross national happiness index. This is the only country in the world, Bhutan, which also is the only country which is negative carbon in the world. So the Bhutan actually prioritized their happiness over all other factors such as wealth, comfort, economic growth, GDP, and all those things. They created an indexation for happiness based on multiple measurable factors, and then an extensive survey with, even at the lowest strata of the population is considered, and the happiness index comes into the picture. However, this happiness index is done on the basis of what we call it as a cantril ladder scale, a ladder with rungs or 10 rungs starting from number 0 to 10 at the top. Rung 10 represents the best possible life, and the bottom rung of the ladder represents the worst possible life. So on which rung of the ladder do we stand at this point in time, or do a smart city stands at this point in time, or a society or a state or a country? Now, if you look at this graph, actually the Finland tops the list of a good happiness with about 7.8 points. And we have the lowest, the most unhappy country in the world is South Sudan with about 2.9 figure. And India, we almost we don't fall in, fall in the category of happy index this thing, because we have only about the happiness index of India is only about 4.01 as we can see it. So these two indices, happiness index and human development index, play a vital role in arriving at the smart city ranking also. As I said, Bhutan is the world's first carbon negative country, and Bhutan absorbs over 6 million tons of carbon annually, while it produces or it emits only 1.5 million tons. That means to the extent of almost about 4.5 tons, it actually caters for the other countries which actually are committing the mistakes, or which are emitting much more than what they actually require. So this is one of the this is only the country which has got negative carbon status. Now we have several problems of a city, scarcity of resources. I would not like to go into all the details because people in the past have covered it. Scarcity of resources. And then we have other important problem is inadequate and deteriorating infrastructure. And we also have energy shortages and price instability. I would like to touch upon this. The large urban populations are major drivers of this trend, and cities often struggle to adequately meet the demand due to lack of key supply, as well as inefficient transmission and distribution systems to the end customer. We have transmission losses, we have unauthorized connections, illegal connections. There are so many loopholes in the entire process. So this we will look at. This is one of the major problems which we need to contain if we want to optimize the energy demand in a smart city. The other environmental program is actually the rise in the global temperature leads to heat, then it spells and dots, cold spells and violent storms, intense flooding, forest fires, etc. Now, health concerns are also there. Human health impacts linked to environment impact, air pollution from burning fossils, we can see actually, and then resulting in poor air quality, smog and respiratory disorders, damage to lung, all these things actually which indirectly demand for the extra energy and also affect the health. When this is actually the case of Delhi, which we have all witnessed in the past, and we are also witnessing now. Now, another global warming impact on cities, whether it is a smart city or just in the process of getting transformed into a smart city, the urban highland effect, which also affects the microclimate, comes into the picture. The reason for urban heat island, there are many, because most of the areas, this happens in the gated communities. This may happen in the clusters where the building clusters actually occupy. There is a lot of reflection from the building surfaces, the rooftop surfaces, the pavement surfaces. All these things actually, higher the reflection we come across, higher will be the heat island effect in the limited areas. And then it's also important to cater for, to find out, to evolve mitigation strategies for how do we take care of the urban heat island effect, mainly in smart cities. So this is also one impact. Now, this heat is directly, makes an impact on the energy demand, and the consumption gets higher and higher and higher. The higher the consumption, higher will be the emission of greenhouse gases, and then higher will be the global warming. And the whole cycle, it's just not a mitigation strategy. The whole cycle has to be taken into consideration. Now, what is also more important is the building's life cycle also gets important. Now, when we assess the energy demand in a smart city, now the topic which is being addressed now, where do we begin? and then where do we end? Now, what happens is, actually, when we take a life cycle analysis of the energy demand and then the energy supply, and especially getting ourselves restricted to smart city project, and then see, mainly we will be focusing on this maintenance operation and then maintenance phase, which is actually the after use phase of the building. Why I am saying this? Because how do you, for a smart city, if you take a particular city into consideration, how do we actually calculate the demand part of it? It's basically how many units have been consumed and how many meters by respective consumer, and all this is aggregated and probably normalized and then come into the picture, and then that is how the demand for the or the consumption or the demand total energy consumption is known, and then that is what it caters to. And it is just not that. It is just not that. We have to add all those things, what we talked about, the transmission losses, the loopholes, and there is a factor of safety. Since I am not very conversant with what kind of factor of safety they add to all these things, and to make the equation, demand and supply equation optimized. But what is important is when the smart city doesn't generate its electricity on its own. So this is how the transmission losses come into the picture. There may be a adjacent site, the neighboring state will be supplying energy to your grid, or far off state will be supplying energy to your grid. All these things actually will get more and more complex. And in addition to it, the entire built environment, whether in the process of converting that, transforming the ordinary city into a smart city, or when the city is growing, what is important is we do not consider the embodied energy part of it at all. So this, which comes actually, is which plays a most important role in the construction phase of the life cycle of a building, or life cycle of buildings. When we take cities, all the infrastructure projects, all the residential buildings, all the projects, everything which gets where the construction industry comes into the picture, the carbon emission also will be extremely high, and which there is a phenomena called the carbon spike phenomena. So which actually contributes to greenhouse gases and increase of greenhouse gases. But this phase is completely gets neglected, which means to say that the energy consumed by a product which is made available in a smart city, all the downstream energy which is consumed by the raw product, it might have been consumed in the neighboring state. It's okay, but it also has to get accounted when we actually talk about the national consumption of the electricity or the power consumption. So this actually, since the focus on operation and then maintenance phase gets focused, where this gets distributed almost over a lifespan of the design life of the building, and then gets distributed. So this is a very common phenomena, and this actually is one of the important phenomena where the smart city whole design has to take into consideration. So in the pre-construction phase becomes the low energy consumption. We have extremely high energy consumption only in the construction phase. And then if that is not considered as a part of the demand and supply chain of power supply, it becomes erroneous. So we need to consider these things in the smart city plan. Now, when we have understood what is smart city, when we take sustainability into consideration, what exactly are smart and sustainable, what is sustainable and smart design, which gets included, what is acronymed as SSD, which calls for a significant level of knowledge and experience while selecting an approach that maximizes the potential for it. Now, what are those parameters which we need to consider in the design? Energy trade-offs, wind direction, sun path, building orientation, passive cooling, passive lighting, ventilation, passive heating, which means to say that the urban design or the smart city has to consider the passive architecture, take into passive architecture into consideration, also along with the energy demand and then supply combination. Just quickly running through some of the core elements of a smart city. We have a smart city will have adequate water supply, assured electric supply, sanitation and solid waste management, efficient urban mobility, affordable housing for the poor, robust IT connectivity and digitalization, good governance, sustainable environment, security of citizens, and health and education. These are actually the core elements of the city which we have talked about. Now, when we come to the smart cities, we will have two pictures. One, there is already an existing city where the buildings exist and there where the progress has already taken place, and then they are quite, some of them might have crossed the design life, some of them maybe midway through, but this we can call it as brownfield development or brown development, where the part of the cities are actually made, and then addressing this and then transforming this part of this aspect of the city, we need to upgrade them. And then how do we upgrade them? We actually need to introduce or retrofit the existing buildings to the smart requirements or the smart system requirements. But these things can be easily accommodated in the new development where new parts are being designed, and they can be easily infused with the principles of sustainability and smart management techniques to deliver efficient citizen benefit services. This could probably, a green development may happen as a figure development or actually around in the outskirts of the cities, everywhere. And actually in the initial session, in the keynote address, BSc Rao also referred to such examples, one of them being Lavasa city, and there are other 2-3 cities which actually he referred, and it's possible. This is very easily possible as compared to the brownfield development. So all these things actually we need to take smart cities into consideration. But when the new cities are being built, the urban designers can play, and then with the present integrating both sustainability aspect of it and then the smart systems can be integrated. So, and some of the cities are actually cities are established with specific purpose. For example, some cities are developed as industrial cities. Some cities have been developed as science towns, educational towns, or in some cases cities acquire these qualities. That we have seen. So it's very important to keep, and then that is how the city gets its identity, and then that is how the culture grows into picture. And that is why the 3 fundamental pillars, what we said in the initial stages, that is how the social, cultural, all these aspects will have to be taken into consideration even while developing a smart city. Now, sustainable cities and then the communities. The cities occupy 3% of the Earth's land, but account for 60 to 80% of the energy consumption, and at least 70% of the carbon emissions. See, it occupies 3% of the Earth's land, contributes about 70% of the greenhouse gas emissions, and account for 60 to 80% of the total energy consumption. In 1990, there were about 10 cities with 10 million people or more. By 2014, the number of mega cities, which rose to 28 from 10 and to 33 by 2018, and it is projected by 2030 there shall be 43 cities exceeding 10 million population. So there are now 48 cities with population between 5 to 10 million. So it is sure that with the kind of projections, I don't know, we will be probably touching the percentage of what is envisaged or what is projected much earlier than the way the cities are growing and the migration is happening. In the coming decades, 90% of the urban expansion will be in the developing world. So this is, though this is a positive from the commercial point of view, from the growth point of view, but there is also a flip side of the side is if we do not take enough precaution, and which we are still developing, and if we do not take precaution, it's going to be a chaos country and then the city. Now, what are the 7 essential features for urban resilience? When a smart city, we call it as a smart city, the resilience, its resilience with which it bounces back is also an important. Now, let us look at what exactly happened just about 6 months back when the whole pandemic thing broke out. We really had no clue actually which were the hospitals. We fell short of beds. We had sudden surge. We had sudden rise in the spread of the disease. We did not know. We didn't have the data. So this is everything. The infrastructure is not sufficient. So I'm sure, so Dr. Raghav has touched upon the disaster management part of it. How do we actually enter this, encounter these unprecedented disasters, which are actually going to be more and more as the time comes, because we are not taking enough precautions. However, coming back to 7 urban resilience, this thing, understand and reduce disaster risk, preparedness and budget for disaster risk reduction, critical infrastructure to cope up with climate change, analyze on hazards, etc., apply and enforce building bylaws, project ecosystems, and natural. See, unless we keep on saying that every citizen should contribute, that is fair enough. But what actually plays a role is the government policies. Government will also make policies, but I'm just at the reminded when I had an opportunity to spend time with Dr. APJ, I asked him this one question: how do you define sustainability? He said in only one sentence, it can be defined as it is a line to be drawn between need and greed, whether an individual is concerned or a society is concerned or the nation is concerned. This is actually absolutely so relevant at this point in time. We actually, what will be the use if we do not follow the bylaws? For example, in Bangalore bylaws, in Karnataka Bangalore bylaws, if you take, everybody violates. Why they are allowed to violate, we don't know. And we also have a wonderful schemes which are known to everybody. Then this scheme is going to come. You have to pay a small penalty or a penalty where all your violations are actually forgiven. And this scheme, we all know, the great Akrama Sakrama scheme. How can we think of building a nation which is sustainable, and we only start talking on paper that we will mitigate all these things? It is not possible. All the bylaws, all the rules, all the policies have to be actually integrated and then have to be followed. Now, how do we coming to the energy classification based on source? We have 2 classifications. Energy can be classified. One as a renewable energy and then the non-renewable energy. The sources of non-renewable energy, as we are aware, coal, the natural gas, oil, petroleum, and nuclear energy, which actually, in case of India, even today, the maximum power generation is to the tune of about, is used by the coal or by the fossil fuel. And Karnataka actually has got a name that it is one of the #1 state in producing the non-renewable energy to the tune of about 30%. So by means of solar, by means of wind, Karnataka produces 30% of the total required energy by using these renewable energy methodologies. Then coming to the other classification, renewable energy, which can further classified as combustible and non-combustible. Under combustible, we have renewable consisting biomass, animal products, municipal waste, industrial waste, etc. And under non-combustible, we have geothermal, solar, hydro, and all these energy, all these non-renewable energy resources which come into the picture. This is the energy mix of India, which we all know, and fossil fuel is still contributes about 65%. And as a rough guide, coal has CO2 intensity of about 1 kg carbon dioxide per kilowatt hour. That means 1 kilowatt hour of power we generate using coal, almost 1 kg of equivalent 1 kg of carbon dioxide as a greenhouse gas emission comes into the picture. With oil, it is about 0.8 kgs, and with hydro and wind and solar actually are less than 50 grams of CO2 per kilowatt hours production. So this is how the renewable energy production comes into the picture. As I said, how embodied energy, these are my two favorite slides. We will not get into the details, but embodied energy went into, there's a huge relation when we take into consideration. For example, a building, let us say a building has got total 13 crore megajoules is the energy consumed, or the in terms of embodied energy, and 1 megajoule is equals 0.28 kg kilowatt per hours, and 3.64 crore units at the rate of 8 rupees per unit, we have about 29 crores. That means embodied energy can be actually converted into the commercial, to understand the commercial value of it. And then when we compare it to the benchmark value, we will be able to analyze and then come at a point how much saving can be, only from the energy point of view, how much saving can be achieved by obtaining or by striking a balance with sustainability principle. The same thing happens with embodied carbon. We also can arrive as equated here. You can go through the slides little later. And now embodied water is also one of the very important aspect of it. When the electricity is produced is entirely based on hydropower, then 1 kilowatt hours energy produced is equivalent to 3.6 megajoules. And in Indian case, when the combination of thermal and hydro power is used to produce the energy, it goes way higher. It becomes 11.4 megajoules. 1 kiloliter of potable water in Indian condition requires 14 megajoules, which again we can, as we calculated earlier, we can actually convert into and understand the implication in terms of Indian rupees, in terms of cost, how much an energy requirement is there. So embodied water also is one of the important aspects which we need to consider in smart city consideration. Now, we have all talking about smart city, and then we also try to compare Indian smart cities with some of the developed nation of a smart city. I have just taken this, I spent a lot of time on making this slide. So I would like to slightly elaborate on this. Now, I have taken two important cities, Bangalore, which is in the process of becoming a smart city, and then the Copenhagen, which is now considered as #1 smart city in the world. At least as of 2019, it had that tag. Now let us look at this for comparison. Now, population of Bangalore in million, if you take, it has got 12.3 million. That is almost about 1.23 crores as per 2020 census, whereas Copenhagen has got 8.3 lakhs. In terms of area, Bangalore is 800 square kilometers, Copenhagen is only 290 kilometers. In terms of power consumption per day in million units, Bangalore consumes about 42 million units per day, whereas Copenhagen consumes almost about 4 times than Bangalore, with much less population and much less area. The per capita income per month in terms of US dollars, 440 in Bangalore, and then in Copenhagen, it is 3,500. Greenhouse gases per capita per year in terms of ton CO2 equivalent, Bangalore has got about 2.42, emits 2.42 tons equivalent carbon dioxide per year per capita, whereas Copenhagen has got 4.38 value. Use of renewable energy in percentage, Bangalore uses 15% of renewable energy, whereas Copenhagen uses about 76% of renewable energy. And this particular figure of 15% is taken is just extrapolated, and then this is not the exact figure because this may be subjected to some kind of a approximation or variation, because Karnataka produces 30% of the total renewable energy production is there. Now, global city index. So this is very unfortunate. Bangalore, when out of survey was done, in taking about 140 countries, which are actually member economies of the United Nations, from global city index, Bangalore stands 95th city out of 140, whereas Copenhagen stands second in the list. Now, from Human Development Index, what we discussed, Bangalore has got 0.682, which is far, far better than as compared to South Sudan. But Copenhagen again stands as the second best city in the world with Human Development Index of about 0.962. And when we take happiness index of the country, Bangalore stands, or this actually, there is no city happiness index available as of now. So it is the country happiness. So I've taken we indicate the country's happiness index only here. And so out of 156 nations, India stands at 140th nation, whereas Copenhagen stands at the second. What do we analyze from this? It is just not possible to compare any city with the kind of population what India has to the city which is already developed, and mostly they have far ahead of it. Look at this, 76% of it is, there is no solar energy in Denmark. All the 75 to 76%, majority of it is by the windmills. Now we have, this Indian subcontinent has got tremendous, and then I'm actually happy with all these constraints India has. We are still a developing nation. We are progressing extremely well, and probably I would like to share with you that India is the only country which actually is doing extremely well as far as 17 development goals are concerned. And whatever may be said, irrespective of the party affiliations, the present government is doing an extremely good effort to at least satisfy the 17 sustainability development goals. Now that is with this, and then the United Nations Environmental Program also calls for some kind of a sustainability development index, which is specific to a particular city, which is particular to a specific state, with reference to taking several indicators into consideration and keeping the circularity into principles. This is required. I will briefly touch upon this in the next few slides, how this is connected with the smart city assessment, etc. Now, the mitigation strategies, how do we see now, how do we meet the demands, energy demand there are two ways. The common sense tells us the one way is we need to optimize the demand by way of smart metering, by way of smart grids, by way of smart engineering, smart energy systems, all that is fine. But there is also a requirement. We need to cut a lot of things. We need to reduce the transmission losses. We need to reduce the leakages. We need to reduce the stealing of power which is happening. We also need to reduce and decarbonize in the entire process of achieving the new, in the continuation of the built environment itself. So what actually, so in a nutshell, the mitigation strategy or the need of the hour has got three components. One is the adaptation part of it. Second one is assess. And then after assessing, the decarbonization actually becomes into the picture. So decarbonization will have three major steps: bring in the energy efficiency and the low carbon, and then adopt clean energy into the smart city. So in terms of when we do the mitigation strategy, how do we adapt? The risk, what do we adapt? Now, risk assessment and then disaster management, which has been already touched by Dr. Raghav, and then critical infrastructure to cope up with the climate change, avoid actions creating for more difficulty in coping with the climate change. Building regulations, we already touched upon. Now, I don't know why we are not able to make all the sustainability laws as mandatory. I would again like to emphasize and congratulate National Building Code for the excellent work done in case of sustainability approaches. And then these are actually to be made compulsory, mandatory, if we really want to establish and integrate sustainability and smart city. Otherwise, it is not possible. Just by including making the systems smart, making the systems efficient, and whatever kind of advanced technologies to bring into the place, ultimately it should be integrated with the human psychologies, and then the people who are the end users have to follow those things, have to respect those things. So which is, unless we integrate them, unless we make use of the advanced technologies, smart cities is not a possibility in the near future. Now, work in partnership with communities, review your adaptation strategy regularly. This is how, as adaptation comes into the picture, decarbonization is, we need to adopt to reduce the fossil fuel burning, and then increase carbon sinks, increase the sequestration carbon areas, reduce deforestation. In case of smart cities, we need to increase the lung spaces, the garden spaces. On one side, whether should we allow the migration to happen and cities get congested and then keep on spending on these things and then make the rest of the 30% of the entire country non-developed? Or should we distribute the entire, all resources, possible resources, that, as in the previous discussion, Dr. Raghav very aptly put it, unless I would recommend to go for the even distribution of all the resources, all the developments across the subcontinent. Maybe there are some areas in the advanced stages, and then we need to distribute and then reduce this rural migration to the urban migration. But anyway, that's I think a far case to know. Re-engineer high energy materials to low carbon economy. That is how the new generation materials are coming into the picture. Introduce smart grids, microgrids. There are several things which are coming into the picture, and increase recyclability and reuse aspects of it. Manage waste very smartly, and this is as far as the mitigation or the decarbonization is concerned. When we also integrate sustainability with several indicators into consideration, we need to classify, as far as the new construction is, green development construction is concerned, we can classify the buildings, the society and the city, whether into non-sustainable, least sustainable, moderately sustainable, highly sustainable. All these classifications is possible with the available data, and especially when the smart city comes into the picture, and then the data, which is the availability of the data is one thing. However, how much is the reliable data? That is most important. I hope with the introduction of the smart systems in place, we will be able to get the reliable data into picture and then make use of them to arrive at several important details into the picture. Now we have already talked about energy, renewable energy and non-renewable energy sources, and the city's energy requirements are extremely complex and they're abundant. Modern cities should improve present systems, implement new solutions in a coordinated way and through an optimal approach. We have talked about it. And in order to achieve optimal energy management in a very complex system like a smart city, not only do most of its energy elements need to be identified and studied, but the implicit relations among them also have to be considered. This is as far as things are concerned. We have talked about grid infrastructure. We have talked about approach 5 main energy areas, which are called actually intervention areas, which have to be considered by the smart energy management approach. And these 5 areas actually are the power generation, storage, grid infrastructure facilities, and the transport mobility. And these are 5 important areas. Due to shortage of time, we are already moving out. I will not touch upon this. In addition to these things, there are smart city can do a lot of things in terms of using hybrid systems on the rooftop. We have wind energy can be adopted on the rooftop. This is one of the rooftop energy systems, and then we can actually adopt passive solar system. Vertical gardening can happen in the urban scenario to increase the carbon sequestration. Hydroponics can also, there are a lot of disadvantages as far as the hydroponics is concerned, but anyway, the soil-less possibility of, and then less water possibility is, should also be looked into the fact. And then the micro turbines, where people are already talking about micro turbines, micro generators, hydroponic farming, what we are talking about, the wind turbines. People are also talking about micro wind turbines, passive architecture we have already talked about, distributed grid system, then net metering, all these things, vertical gardening, which also is one of the important factors where we can increase the carbon sequestration. And then all these things actually can be adopted by a smart city while implement, and that is how we will be able to integrate sustainability, energy aspect, and other features of sustainability and things. Now, these are some of the things which can be implemented. This is an air pollution tower, which actually is claimed in China, which actually is claimed as one of the tallest in the world, in northern China part of it. You can get details. And this possibility also has to be taken into consideration when we start talking about the energy demands in smart cities. I don't know, for example, in Delhi, how many of such air pollution towers may have to be implemented in due course of time if we do not take necessary steps. These are actually smog-free towers. You can get into the details from the net. All these things are coming into the picture. And even speed humps. Speed bumps at one group of bumps per 800 meters in an urban scenario causes more fuel to be burned. See, if we have these kinds of things, which actually can be transformed into these kinds of 3-dimensional speed breakers, where bumps, the fuel increase is 60% for a bump scenario, as explained above. Bumps, we have 11.74 liters consumption per 100 kilometers with bump grid, speed humps, as we encounter on our roads, whereas 7.31 liters per 100 kilometer is without bumps. So this is just a scenario where we also need to take into consideration. In conclusion, it's time to reconsider all our assumptions about urban planning, and it is my belief that the urban planning process needs a new overarching direction if it is going to solve the problems we face now and those we will face in the future. Challenges such as climate change, resource depletion, and our rapidly expanding population cannot be met through existing planning approaches. The approaches should be smart, and that is how it is just not only the energy requirement, several other factors have to be taken into consideration for a smart city to become truly effective and truly successful. Thank you very much, and my apologies for exceeding the time. Over to you, the organizer. Thank you very much.
Thank you, sir. We have two questions from the participants. Shall we look into?
Yeah.
Okay. The first question
read.
it is from Dr. G. Rajshekar. The question is, what are the yardsticks to withdraw smart city if ROI is not picking up? If return of investment is not picking up?
Yeah, I think Dr. Rajshekar has left. That's what I saw in the box. But for the general information, see, it becomes at a policy level. In the initial stages, it's going to, as far as India is concerned, return of is not going to be in the near future. This is something like at a policy decision, at a government policy level, it has to be taken into consideration. We need to account for a long return of investment taking into consideration.
Sir, the next question.
Yeah.
What are the matrices that are required to be updated in a smart city?
What are the
metrics? What are the metrics that are required to be updated in a smart city?
Sure, I think that is what we discussed. All salient features of the smart city. What are the core elements that are required in the smart city? We talked about energy requirement. We talked about the renewable energy matrix. All these things we discussed. The entire session was discussing the matrices of the smart city requirement. I mean, the person who has asked this question can go through the presentation once again, and then if there is any requirement, actually the questions can be emailed. I have given the email, which will be also answered by me, and then which can be circulated.
Okay, thank you, sir. Okay, now into the final part. For a provocative and intriguing session, by showing us the humiliating effect of over-exploiting the environment, he also stressed that smart cities should gradually migrate to renewable energy scheme, while mentioning the 7 essentials for urban resilience. And not to mention, the slides were also very eye-catching and very engaging. The whole session was very engaging. Ajit sir, for the wonderful session. Thank you, sir.
Thank you. Thank you, Umesh.
Okay, we have come to the end of today's FDP program. So by this, today's program. Thank you, everyone. We'll meet again tomorrow. Thank you.
Yeah, thank you.